Hello, if you are planning to study Azure networking, this practical hands-on lab exercise video will definitely help you. I have included almost all Azure networking components and services in one single video. In this video, you will begin with understanding Azure networking basic concepts, then creating and implementing hybrid networking, Azure Firewall, Azure ExpressRoute, Azure Front Door Service, Azure Virtual Network Service Endpoints, configuring Azure DDoS protection as well. In this workshop, there are 11 labs and 63 exercises which you can follow all by yourself. So without wasting any more time, let's get into it. So in this lab exercise, I'm going to give you an introduction to Azure networking. And within this lab exercise, we are going to create virtual network and subnets. We're going to create DNS settings in Azure, and we are going to create a couple of virtual machines placed under these virtual network, and we're going to use the global VNet peering to connect these two resources. And let's go and do that. Let us go ahead and create those virtual networks and the subnets we talked about. You can create these resources in multiple places. You can either go to the global search box and type in the resource and select the resource and create it. Or you can click on create a new resource here and you can create one as well. Another option is go to the resource group and you can create the resources within your resource group itself. So this is the resource group what we are going to use. I'm going to click on create here to create our first resource. So within the search box, type in virtual networks and click on create. Make sure you have your right subscription selected and the resource group. For the resource group, you have another option. You can create a brand new one if you choose to do so. So we're going to select an existing one. The first VNet we are going to create is for the core services. And within the core services VNet, we're going to create these subnets as well. One for the gateway, one for shared services subnet, database subnet, and public web services subnet. The region we are going to pick is East US. And the network address range is 10.20.0./16. So let's keep East US as the region. That's what we want. And click next for IP addresses. Under the IP address tab, you can see by default the range which is given is 10.0.0.0/16. We are changing it to 10.20.0.0/16. This is going to give us enough IP address. Scroll down until you find add subnet. Click on add subnet. The first subnet we are going to create is gateway subnet. So give a name for your gateway subnet. And the subnet IP address range is 10.20.0.0/27. We're going to leave rest of the information as default as of now. We're not going to select any NAT gateway or any service endpoints. We'll come back to those later. At the bottom, click on add. Now we have created the first subnet. Click on add subnet again, and this time we are going to create shared services subnet. Give a name for your shared services subnet, and subnet address range is 10.20.10.0/24. Again, click on add. Now we have our two subnets created. One more time, hit on add subnet. This time add the database subnet and give the address range as what we want, which is 10.20.20.0/24. Click on add, and the fourth subnet we are going to create is public web service subnet, and the IP address range we are going to give is 10.20.30.0/24, and click on add. Now we have all the subnets we need to create for the core services virtual network. To complete the whole process, click on review and create. This will go through a validation, and after validation, you can click on create. Okay, validation has been passed. Click on create. All right, so our deployment is completed. Click on go to resource to see the VNet you created and the subnet. So on the left hand side of the page, you can click on address space to find out what's your VNet address space. And you can click on subnets to find all the subnet you just created and the available IP address within those subnet. Now that is completed, now head back and create the next VNet, which is manufacturing VNet. And within that, we are going to create this VNet in West Europe, and the IP address range is 30.0 instead of 20. And we are going to create another 4 subnets within the manufacturing VNet. So I'm going to go back to home. This time click on create a resource. I'm going to type in virtual networks and select the virtual network. Click on create, and I'm going to select the existing resource group we've been using. Under name, I'm going to give this time manufacturing VNet, and the region, instead of East US, we're going to select West Europe. So select the region and go to IP addresses. So this time, instead of 10.0, we are going to put 10.30.0.0/16. And after that, click on add subnet. The first subnet is manufacturing system subnet, and the IP address is 10.30.10.0/24. Click on add another subnet. This time it is sensor subnet 1, and the IP address is 10.30.20.0/24. Click on add the third subnet. The third subnet is called sensor subnet 2, and the address is 10.30.21. Click on add, and the last subnet is sensor subnet 3, and the IP address range is 10.30.22.0/24, and click on add. So we have all the subnets created or needed for the manufacturing VNet. Click on review plus create. After the validation, click on create. While that is happening, let's look at the third requirement. The third requirement is to create a research VNet in Southeast Asia, and the IP address range is 40. And we only need to create one subnet in the research VNet. So let's go ahead and do that. All right, so our resource is created. Let's quickly check the subnet. Yep, all of the subnets required is created. Now I'm gonna go back to home and this time search for virtual network. Click on create a virtual network. I'm going to select an existing resource group we've been using, and under name, we're going to give research VNet. That's our third VNet we are going to create. Under region, this time we have to place it in Southeast Asia. So select Southeast Asia as the region. Go to IP addresses. The range this time is 10.40. So type in 10.40.0.0/16. Scroll down till you find the subnet. You don't have any subnet by default, and create your first subnet. The subnet is research system subnet, and provide the subnet address range and click on add. Click on review plus create. After the validation, click on create. Let's go to resource and check the address space, which is 40. That is what we wanted. And subnet, we only need to create one subnet for the research subsystem. All right, so our task is completed. So we wanted to create 3 different VNets for this company. The first is the manufacturing VNet. We had to create 4 subnets. East US region, we have to create the core services VNet, which had another 4 subnets. In Southeast Asia, we have to create a VNet and a subnet for the research system subnet. All right, so let's go and do another exercise. In this exercise, what we are going to do is we are going to configure DNS name resolution for a Contoso Limited company. And we will create a private DNS zone named contoso.com and link the VNets we just created for registration and resolution. And then we create 2 virtual machines and test the configuration as well. So let's go ahead and do that. So now that we have created all the subnets and the VNets we need, let's go back to the home page. This time on the global search box, type in DNS. So select the private DNS zones. Under the private DNS zone, click on create. We are going to keep the same settings what we have been using so far. So let's select the existing resource group. Under the instance details, give the name for your private DNS zone. I'm going to call it as contoso.com and click on review plus create and click on create. Looks like our resource is created. Let's click on go to resource to verify if it is created. All right, so our contoso.com zone or private DNS zone is being created. Now the next task is to link the subnet for auto registration. So to do that, go under settings and click on virtual network links and click on add. So under the subscription, leave the default subscription and expand the virtual network. We have to create the auto registration on the core services VNet. So select the core services VNet and make sure you select the configuration to enable auto registration and hit OK. Oops, I forgot to give the link name. So the first task is to give the link name. So I'm going to call it as core services VNet link. Scroll down and click OK. So right now it is creating the VNet link with auto registration. While that is creating, now let's go and create auto registration on other two VNets as well. So click on add, give a name for your link. So I'm going to call this time it is manufacturing VNet link. And under virtual network, I'm going to select the manufacturing VNet and scroll down until you find the configuration and make sure you enable the auto registration and hit OK. And I'm going to create one more. This time I'm going to call it as a research VNet link and select the VNet as a research VNet and repeat the same step what we have done in the past to exercise to enable auto registration and hit OK. Alright, so now it is deploying the other two VNets. As you can see that one of the link has been successfully created and auto registration is being enabled on virtual network, which is core services VNet. So we'll wait for another couple more minutes to complete the whole step on all three VNets. Alright, so looks like all three of the VNet has been enabled for auto registration. So that task is complete. Now we have completed by creating the private DNS zone. We created the link subnet for auto registration. The next task is to create a virtual machine to test the configuration. So let's go ahead and create a virtual machine. So we're going to create the virtual machine using the PowerShell. So I'm going to use the Cloud Shell. You can find the Cloud Shell by clicking on this Cloud Shell icon. So you can create a virtual machine in multiple ways. I have created many videos in the past showing you how to create the virtual machine using the GUI. So right now I have a template, so I'm going to use the template to create it. All right, so the deployment of the virtual machine is being executed. So let's go to virtual machine and see if we can find anything. Yep, we can see that there are two VMs is being created. One is a test virtual machine 1 and test virtual machine 2. Both are created under the resource group we just talked about. And both of these virtual machines are in East US. Right now it has been creating. You can see other details like what's the size of the virtual machine. Alright, so both the virtual machines are created. You can see the status changed from creating to running. That means the virtual machine is created. So let's go and verify the records are present in the DNS zone. So on the Azure portal, let's go to the private DNS zone. Select the private DNS zone we just created. Click on the overview tab and scroll down. Now you should be able to see both the test VM, which is automatically registered here, and it has the A record and the value, which is IP address, which is registered for these VMs. Now that is been completed. Now let's go and connect to test the VMs using the RDP connection. So go to virtual machines, select one of the virtual machine, which is I'm going to select test VM1, and at the top click on connect. So I'm going to connect via RDP. So click on RDP. So you can connect the RDP via public IP address. So click on download RDP file and click on open, connect. Provide the username. The username is test user and the password and hit OK. Yes. Now that our test VM1 is launching, I'm going to go and connect to test VM2 as well. Go back to the virtual machine. This time click on test VM2. Click on connect, download RDP file. Make sure you select the public IP address and click on download RDP file and open the VM2 RDP file. Click on connect. Provide the username, put the right password and hit OK. Yes. Alright, so now it is connecting to the test VM2. So let me minimize that, put it to the side. Our first VM is booted up and the second VM is booting now. So let's see if we can connect to these both virtual machine using ping command. So let's go to run and go to command prompt and try to ping the second VM from the first one. So I'm going to execute command ping test VM2 with the DNS name .contoso.com. The request timeout is because the Windows firewall is enabled on the VM. So let's go to the VM2 and go to the command prompt and ping the test VM1. So the request timeout is expected because the Windows firewall is on. Alright, so congratulations. So you have created the private DNS zone and added a name resolution and auto registration link and tested the name resolution in your configuration. Now that we have completed the second exercise, which was about DNS zone registration, in this exercise, we are going to learn how to connect to Azure Virtual Network using global VNet peering or global virtual network peering. Let us look at the task we are going to perform. First, we are going to create a virtual machine to test the configuration. Then connect the test VM using the RDP. We're going to test the connection between these two VMs and create VNet peering between core services VNet and manufacturing VNet. That's the important task. And then we are going to test the connection between the VMs as well. So let's go and do that. So first step is to create a manufacturing virtual machine. Like the last exercise, I'm going to use Azure Cloud Shell to create it. And I'm going to execute the command to create the virtual machine like last time. So in the background, now it is creating a virtual machine in the manufacturing VNet subnet. So let's minimize this. Let's go back to virtual machines and we should be able to see another virtual machine creating in some time. Let's do a quick refresh to see if something is happening. Yep, I can see that I'm going to minimize the Cloud Shell. So our command is being executed. You can see at the top, we are creating a brand new virtual machine, this time under the manufacturing department. The status is creating, and again, it's a Windows virtual machine, the same configuration as the other two VMs we created. So let's wait for a couple more minutes to complete this. All right, looks like our virtual machine has been created and it changed the status to running. So we can go back to the virtual machine and log in to the virtual machine for the first time. Under overview, click on connect, select RDP, and make sure you select the public IP address unless you are inside your organization network, and click on download RDP file. And this time we are going to open the manufacturing VM RDP. Click on connect, give a username, give the right username and the password. Click OK and click yes to connect to the virtual machine. So let's check the IP address of this manufacturing virtual machine. So I'm going to go to PowerShell and run the command called ipconfig. The IP address of this virtual machine is 10.30.10.4. So let's minimize that. Now we know the IP address of the manufacturing VM. I'm going to go back to our test VM in the core network. So I'm going to go back to the virtual machine. This time I'm going to go to test VM. That's in a completely different network altogether. Click on connect and click on RDP, download RDP file and open. Click on connect. On this virtual machine, I'm going to open the PowerShell and test the IP address. Alright, so the IP address of the test virtual machine 1 is 10.20.20.4. So let's keep it aside. Alright, so now we have two virtual machines. One is the manufacturing VM and the test VM. Both are in two different VNets. If I go back to the initial diagram, I can quickly show you. Our first VM is in the core services VNet and VM is placed under the subnet. And the second VM is the manufacturing VNet that is placed under the manufacturing system subnet. So we don't have any VNet peering in between. So technically, if you try to connect or ping these two virtual machines, the connection should fail. So let's go and find out. So on the manufacturing VM, I'm gonna try to connect to the VM1. Type in testnet connection, the IP address of the first VM, which is 10.10.20.0.4. We're gonna connect via port 3389. Now it is testing the connection or attempting to connect via TCP. We should ideally get a test connection fail message. So the message here is TCP connect to the virtual machine 1 is being failed because there is no connection between these two networks. If we try to do the same connection on the other virtual machine, we should get the same message again. Test net connection. I'm going to type in the manufacturing IP address 10.30.10.4 and port 3389. Hit enter. And we should get a similar message because there is no connection between these two networks. All right, so we get the failed message. Now let's go and create the VNet peering between these two networks. So on the Azure portal, go back to your home and you can go to your virtual networks. First, let's select the core services VNet. Under settings, scroll down till you find peerings and select that. So we don't have any peering yet, so click on add. Under the peering link name, give a name called, we are trying to create a connection from the core services VNet to the manufacturing VNet. So I'm going to call it as core services VNet to manufacturing VNet. Traffic to remote virtual network, I'm going to select allow, which is default. And traffic forwarded from virtual network, I'm going to enable allow, which is default. And virtual network gateway or route server, I'm going to keep it as none. So that's the first part. So the first part is this virtual network. The next part is the remote virtual network. Now we have to fill the details for the remote virtual network. First, provide the name, which is this time it is manufacturing VNet to core services VNet. Virtual machine deployment type as resource manager. Subscription, keep the existing subscription. Under the virtual network, select the manufacturing VNet because that is our remote or the VNet we are trying to create or the VNet we are trying to connect. And I'm going to keep the rest of the value as default, which is traffic to remote virtual network allow and traffic forward from virtual network or the remote virtual network is allow. And virtual network gateway or route server is none by default and click on add. Now that our peering is enabled, let's go refresh this page. So we are under core services VNet. Under peering, we can find that there is a peering created. The status is being updating. So at the same time, we can go to the other virtual network, which is manufacturing VNet. And under settings, go to peerings. We should be able to see that there is a peering created and the status is connected. Let's go back to the virtual network and to the core services, peerings, hit refresh, and the status is changed to connected. So now we have the peering connected between these two VNets. So now let's go back to the virtual machine. We do have these two virtual machines anyway here. I'm going to execute the command one more time. So we are trying to connect to VM1. At the same time, I'm going to the VM1 and we are going to try to connect to the manufacturing VM as well. All right, so the connection is successful. So as you can see that the VNet peering is been successfully enabled. So congratulations. So you learned how to connect two networks using VNet peering or virtual network peering or global VNet peering. So in this lab exercise, we are going to design and implement hybrid networking in Azure. Within this lab, we are going to create and configure Azure Virtual Network Gateway, which is necessary step to create this connectivity between your on-prem and Azure site. And we are going to create Azure Virtual WAN using Azure portal as well. So you're going to see two types of hybrid networking connection in this lab. I hope you find it useful. Let's go and do that. The first exercise we are going to do is to go and create and configure a virtual network gateway. Our sample environment looks something like this. The first step is we are going to create these two VNets, core services VNet and manufacturing VNet. And we're going to create two VMs and we're going to place two VMs in both of these subnets. So to create our first task, what I'm going to do is I'm going to use a JSON file or a ARM template to create these core services VNet and the manufacturing VNet. So if you want to understand how to create it using GUI or this graphical user interface, I have created another video which talks about basic understanding about how you can create these virtual networks and subnets using Azure portal. Let's go to our resource group. Let me quickly show you. We have a resource group called resource group 1. It's an empty resource group. I don't have any resource at the moment. So let us deploy this ARM template. All right, so it looks like our resources required for us to start the exercise has been created. Let me go back to resource group, quickly minimize this window and refresh. Yep, we can see that there is a new resource group created called Contoso resource group. And as you can see that all three virtual networks, which is required for us to do this exercise to create the virtual network gateway, is being created. And all three VNets are in different location. One is in East US, another one West Europe, another one is Southeast Asia. Now that we have created this core services VNet and manufacturing VNet, let's go create a core services virtual machine and a manufacturing virtual machine. So I'm going to again execute a command which is going to deploy two virtual machines in both of these VNets. All right, so first let's create a virtual machine in the core services VNet. And next I'm going to create another virtual machine in the manufacturing VNet. Go back to the Azure portal and click on refresh. So our core services virtual machine is created. You can see that the status is changed from creating to running. And we are waiting for one more virtual machine to be created here. That is in the manufacturing group. These steps are not the main step which I want to show you in this lab. These are all the steps which I need to complete before showing you how to create a virtual network gateway so that you know how to implement those. Ideally, when we try to connect the virtual machine from one VNet to another one, it should fail because there is no VNet peering or gateway transit in between. So then what we're going to do is we are going to create a virtual network gateway and we are going to enable or establish the connection so that the virtual machine in the core services VNet will be able to communicate to any virtual machine in the manufacturing VNet. All right, so now we have both of our virtual machine in running state. Now let's log into both of these virtual machines. First, go to the core services virtual machine, click on connect and click on RDP. Make sure you choose the public IP address to connect. Download the RDP file and click on open. Connect and provide the username and password and hit OK. Click yes. Let's give it some time so that we can select yes to accept the network settings, things like that. So say yes to accept the networking. So I'm going to minimize it. I'm going to do the same thing to the manufacturing virtual machine. So let's go back to the virtual machine. Click on manufacturing virtual machine, connect RDP, download RDP file and open the manufacturing VM RDP. Click connect, provide the username and the password, click OK, yes. And let's wait for this machine to boot up. All right, accept the network and let's minimize this window and open both of these virtual machines side by side. So it is easier for us to navigate. All right, so on the left hand side, we have the core services virtual machine and on the right hand side, we have the manufacturing virtual machine. So I'm going to open the PowerShell on both of these virtual machine and I'm going to type in ipconfig. The IP address of the core services VM is 10.20.20.4 and the manufacturing VM is 10.30.10.4. Now let's see from the manufacturing VM, we are able to connect to the core services VM. So I'm going to execute a command called test-net connection, the IP address of the core service VM and using port 3389. And I'm going to run that command and let's execute that command. So it is waiting for the response. It shouldn't be able to connect because there is no peering or gateway transit between these two networks. So the connection should fail or we should get a timeout status. We get a message stating that TCP connection to the VM is failed. Now let us go and create the core services VNet gateway. That's the main task. So first let's go back to the Azure portal. On the global search box, type in virtual network gateway. So select the virtual network gateways. As you can see, we don't have any at the moment. So click on create, select the subscription. So the resource group can be only selected when we select the network. So we can come back to that later. Under name, give a name for the instance. I'm going to call it as core services VNet gateway. and our VNet is anyway in East US. So let me quickly check the diagram. Our core services VNet is in East US and the manufacturing VNet is in West Europe. Under gateway type, make sure you select VPN because we are trying to create a VPN here. Under VPN type, select route based, not the policy based. Under SKU, so there are different types of VPN plans. For the lab, we're gonna keep it as VPN Gateway 1. Under generation, I'm gonna keep it generation 1. And this is where you will pick the virtual network. So I'm gonna select core services VNet. So if you scroll down, you will be able to find the core services VNet. Gateway subnet is automatically selected because when we created these VNets, we created the gateway subnets already. Under the public IP address type, I'm going to keep it basic. And under public IP address, click on create new and give a name for your public IP address. So I'm going to call it as core services gateway -IP. So I know that this IP belongs to the gateway public IP address. And I'm going to keep the rest of the values to the default, like enable active mode. I'm going to keep it default, and BGP also I'm going to keep it default, which is disabled. So now I can go ahead and create. It's going to go through a validation and we're going to click on create. All right. So this process is going to take 45 minutes to complete, minimum 45 minutes to complete. So what we're going to do is we're going to go and create the manufacturing VNet gateway now. And then we will come back to this. So right now it is creating the gateway on the core services VNet. So let's go back to home. Let's click on virtual network gateways. As you can see right now, we don't have any because the other one is creating. So I'm going to click on create one more. Subscription. I'm going to call the instance this time. It is manufacturing VNet gateway. And we know that manufacturing VNet is based out in West Europe. It's not in East Europe. So I'm going to select the region as West Europe. So select the region and change it to West Europe. It's pretty much the same like what we did last time. Select the gateway type as VPN, VPN type as route based. SKU, I'm going to change it to VPN Gateway 1. Generation, we are going to retain generation 1. Virtual network, because we selected the right region, it automatically showing us there is a VNet available. Do you want to associate that? So I'm going to pick the manufacturing VNet, and there is already a subnet available within the VNet. So I can quickly go and show you. So let me quickly show you these virtual networks and the gateways which I'm talking about. So it is all placed under condenser group. If you look at all the resources, let's pick the core services VNet. On the left hand side under settings, you can check the address space. So you can see that it is 10.20. And if you go to subnets, you can see how many subnets which is part of this. So for the gateways, we are always using the gateway subnet. So the address range is correct. Change the public IP address type to basic. Like we don't want standard in this exercise. Public IP, I'm going to create new, and I'm going to call the public IP address manufacturing VNet gateway IP. Rest all the values are default. So I'm going to click on review and create. After the validation, click on create. All right. So this is also going to take another 45 to 50 minutes. So I'm going to pause the video. We will come back later after these two virtual network gateways has been completed. All right. So that's a great news. So both of our virtual network gateways has been deployed. So we can click on go to resource to go directly to the virtual network gateway. So this is the first gateway, which is for the core services VNet. Now let's use this to connect to the manufacturing VNet. So to connect to another VNet, this is the important step. So find the gateway which you want to connect to. Under settings, click on connections. So we don't have any connections at the moment. So what we are going to do right now is to add a new connection. So click on add. First, provide a name. So I'm going to call it as core services gateway to manufacturing gateway. Connection type as VNet to VNet. So we have three different types: VNet to VNet, site to site, and ExpressRoute. So I'm going to select VNet to VNet. Then the first virtual network gateway type as, we're going to keep it as our current gateway itself, that is the core services VNet. And the secondary VNet is what we're going to choose. So we're going to choose our secondary gateway as the manufacturing VNet gateway. So provide a shared key. So I'm going to call it as ABC123. Leave the rest of the default as it is because we are not doing any advanced testing. So I'm going to leave the use Azure private IP address and enable BGP unchecked. Under IEK protocol, select IEK version 2. Subscription, there is no change. Resource group, there is no change. And location, it is currently East US. So click on OK. So we are creating a new connection from the core services VNet to the manufacturing VNet. Now we have to do the same thing on the other VNet as well. So I'm going to go back to my Azure homepage. I'm going to go to my resource group, Contoso resource group. This is where all of our resources are placed. So let's sort by type. So we're going to select the virtual network gateway for manufacturing. So I'm going to scroll. Yeah. So I can see that there is manufacturing VNet gateway. Again, we are going to follow the same steps. Under settings, click on connections. We don't have any connections yet. So click on add, give a name. So this time I'm going to call it as manufacturing gateway to core services gateway. Connection type as VNet to VNet. First gateway is our existing gateway and secondary gateway is the core services VNet gateway. And the shared key what we have given is ABC123. So I'm going to give the same here as well. Rest all the values. I'm going to keep it as default and click OK to create the connection. So let's wait for both of these connections to establish. Then we are going to verify the connections. So one connection is being established. So we are waiting for another connection to be established as well. All right. So both of these connections are established. So let's go back to our gateway, close this window. You can see that the core services gateway to manufacturing is connected and the manufacturing to core is unknown. So maybe a quick refresh will help to update the status. So I'm going to quickly refresh. So let me quickly refresh the whole page itself. All right, it's still showing unknown. So let me go back to the other VNet, core services connections. Okay, it's still showing unknown. So we will wait for another couple more minutes. Let's refresh one more time. Yep. So both of the status of these two gateways are connected. So now we can go and test the connection between the virtual machines. So I'm going to launch the virtual machine one more time. So under the manufacturing VM, last time when we tried to connect, we got the connection timeout and the failed message. So what I'm going to do now is I'm going to test the connection one more time. So let's try to ping the virtual machine, which is our core services virtual machine. Yes, this time we are able to connect to the virtual machine. All right, so congratulations, you have configured a VNet to VNet connection by using the Azure Virtual Network Gateway. So one of the main tasks what we have learned in this exercise is creating the gateway and making sure that we learn how to connect these two gateways together so that the resources like virtual machines or other resources can communicate between these virtual network. So one way to communicate is the VNet peering. Another one is to use VNet gateways. This is applicable to on-prem as well. Now that we have learned about how to create a virtual network gateway and establish a connection, in this exercise, we are going to learn how to create a virtual WAN using Azure Portal. So these are all the main tasks we are going to perform in this exercise. We're going to create a virtual WAN. We're going to create a hub by using Azure Portal, then connect a VNet to the virtual hub. And towards the end, we will clean up all the resources what we created for this exercise. So let's go and do that. So to create a virtual WAN, go to the global search box and type in virtual WAN and select that. We don't have any virtual WANs. So let's go and click on create a new virtual WAN. So I'm going to select a existing resource group what we have. We are going to use the Contoso resource group we used for creating the virtual network gateway. And I'm going to retain the East US as the resource group location and give a name for your virtual WAN. So I'm going to call it as Contoso virtual WAN. Under type, you have basic and standard. I'm going to select standard and click on review and create. Click on create. All right, so our virtual WAN is created. Click on go to resource. So we will come back to this page later. The next is we need to create a hub. A hub contains gateway for site-to-site, ExpressRoute, or point-to-site connectivity, and it can take up to 30 minutes to create the site-to-site VPN gateway in the virtual hub. To create a hub, go to a virtual WAN. So right now we created this Contoso virtual WAN. On the left hand side, under connectivity, click on hubs. So we don't have any hub at the moment, so click on new hub. So subscription and resource group is by default chosen because that is coming over from the virtual WAN itself. Region, I'm going to pick as West US. Give a name for your hub. I'm going to call it as Contoso Virtual WAN Hub West US, and give a private address space for your hub as well. So I'm going to give 10.60.0.0/24. So next, click on site to site. The question here is, do you want to create a site to site VPN gateway? Select yes. AS number is autonomous system number. So this cannot be edited. So under gateway scale units, select one scale unit to 500 Mbps into 2. Routing preference, there is Microsoft Network and Internet. I'm going to keep it Microsoft Network itself. And we are not going to look into point to site or ExpressRoute at the moment. So click on review and create. So this is going to take after validation, this process of creating a hub is going to take at least 30 to 40 minutes. So I'm going to pause the video and we will come back to this later after completing this step. Perfect. So after 35 minutes, our deployment is being successfully completed on the virtual hub. So click on go to resource. So this is our virtual hub. Go to your virtual WAN. On the left hand side, under connectivity, click on virtual network connections. So here, click on add connection. Provide a connection name. I'm going to call it as Contoso Virtual WAN to Research VNet. Under hubs, select the hub which just now created. No changes to the subscription. And under resource group, select the Contoso resource group. Under virtual network, select Research VNet. Propagate to none, select yes. Associate route table, select default and click on create. So right now what it is doing is creating a pairing between the Contoso virtual WAN and your research VNet. This is another way you can create a connection between these two VNets. Alright, so we successfully added pairing. I'm going to go back to the main page and hit on refresh. Alright, so now we have established a connection between this virtual WAN and the research VNet. And the connection type is successful and the connection status is connected. So congratulations, now you have learned how to create a virtual WAN and a virtual WAN hub and connect to the research VNet to the hub. So what I'm going to do next is I'm going to delete all the resources what we just created so that it is not going to exhaust any cost in my subscription. So thank you so much for watching and I hope the information provided in this video is helpful. So to delete all the resources within the Contoso resource group, I'm going to use a command -force as job so that this command execute asynchronously and it is going to remove everything within that subscription. So in this lab exercise, I'm going to show you how to design and implement Azure ExpressRoute. So let's go and do that. So to connect your Azure Virtual Network and your on-prem network via ExpressRoute, you must create a virtual network gateway first. A virtual network gateway serves two purposes: to exchange IP routes between the network and to route network traffic. So what we're going to do right now is we are going to create a VNet and we are going to create a gateway subnet, and then we are going to create the virtual network gateway. So to create a gateway and VNet, let's click on create a resource, search for virtual networks and select the virtual network and hit on create. So make sure you select your right subscription. I'm going to click on create a new resource group. I'm going to call it as Contoso resource group and give a name for your VNet. I'm going to call it as core services VNet and the location I'm going to retain as East US. Click on IP addresses. So by default, the IP address range or IP address space is 10.0.0.0/16. I'm going to change it to 20. So the address space what we are going to assign to the core services VNet is 10.20.0.0/16. Scroll down till you find the subnet and click on add subnet. Give a name for your subnet. I'm going to call it as gateway subnet and then provide a subnet address range. I'm going to assign 10.20.0.0/27 and leave the rest of the values to the default. So we don't want a NAT gateway or any other service endpoint. So click on add. Now we have given all the details for a virtual network, address space, and a gateway subnet. Click on review plus create. After validation, click on create. Alright, so our virtual network deployment has been completed. So click on go to resource to see the resource. Within the VNet, you can go under settings to check your address space. You can verify and make sure that the one which you have given is what it is assigned. And if you scroll down and click on subnets, you will be able to find the subnet you created. So if you want to create additional subnets, all you have to do is click on add a subnet, give a name and a different IP address range. Now that we have created the VNet, next step is to create the virtual network gateway. So I'm going to go back to my Azure portal homepage, click on create a resource. This time search for virtual network gateway. So select virtual network gateway and click on create. Under creating virtual network gateway, make sure you select the right subscription. Give a name for your instance. I'm going to call it as core services VNet gateway. Pick a region where you want to host this gateway. I'm going to keep it as East US. Under gateway type, instead of VPN, select ExpressRoute. SKU, you have multiple options. I'm going to keep it as standard. If you want high performance or ultra performance, you can select that. So for the lab, I'm just going to keep it as standard. Under virtual network, select the virtual network you just now created, core services.vnet. And the subnet is by default selected, one which we created for the gateway subnet. Scroll down under public IP address, click on create new and give a public IP address name. I'm going to call it as core services VNet gateway IP. SKU, I'm going to retain it as basic, and under assignment is anyway it's not configurable for us. And now hit on review plus create. Click on create. So this step is going to take at least 45 minutes to complete. So I'm going to pause the video. We will come back later after completing this step. The next step after this we are going to do is we're going to provision an ExpressRoute circuit. So I will see you in a bit. Alright, so after 50 minutes it completed creating the virtual network gateway. So click on go to resource to see the virtual network gateway. Yep, we have created the virtual network gateway. We don't have any connections or configuration yet. We'll come back to this later. Now in this exercise we are going to create an ExpressRoute circuit using the Azure portal. So first let's go ahead and create and provision an ExpressRoute circuit. Alright, so to create an ExpressRoute, just click on create a new resource, search for ExpressRoute, select ExpressRoute and click on create. Leave the subscription as default. Under resource group, I'm going to create a new resource group. I'm going to give a name as ExpressRoute resource group. Click OK. Under region, I'm going to select East US 2 and I'm going to call this ExpressRoute as test ER circuit and click on configuration. Under configuration, I'm going to leave the port type as provider. Create new or import from classic, I'm going to select as create new. Under provider, select Equinix. I'm going to select the peering location as Seattle. Bandwidth, I'm going to pick 50 Mbps. Under SKU type, for this lab, I'm going to pick premium. Under billing model, metered or unlimited, I'm going to pick unlimited. Allow classic operations, you can keep it no. And hit on review and create. So right now it is doing a validation. After the validation passed successfully, you will be able to create this resource. Click on create. While that is creating, so I just want to explain a few things to you. So under port type, this determines if you are connecting to a service provider or directly into Microsoft Global Network at a peering location. Creating new or import from classic, this determines if a new circuit is being created or if you are migrating a classic circuit to Azure Resource Manager. Provider is the internet service provider who you will be requesting your service from. The peering location indicates the physical location where you are pairing with the Microsoft. This is not linked to the location property, which refers to the geography where the Azure Network Resource Provider is located. While they are not related, it is a good practice to choose a network resource provider geographically close to the peering location of the circuit. SKU determines whether an ExpressRoute local, ExpressRoute Standard or an ExpressRoute Premium add-on is enabled. You can specify local to get the local SKU, standard to get the standard SKU, or premium for the premium add-on. You can change the SKU to enable the premium add-on later. Please note that you cannot change the SKU from standard to premium to local. Billing model determines the billing type you can specify, which is metered or a metered data plan, and unlimited for an unlimited data plan. You can change the billing type from metered to unlimited anytime, but you cannot change the type from unlimited to metered. And allow classic operations means that you will allow classic virtual network to be linked to the circuit. Alright, so now our ExpressRoute circuit is being deployed. So let's click on go to resource, and we have our test ER circuit is created. Now let's go and retrieve our service key. So let's go back to the home page, select the ExpressRoute circuit we just created, test ER circuit, and under the overview tab, this is where you will be able to find the service key. And your service provider will need the service key to complete the provisioning process. The service key is specific to your circuit, so you must send the service key to your connectivity provider for provisioning. And on this page, you can check the provider status as well. As you can see that the provider state is not provisioned because we have not provisioned it yet. And the circuit status is enabled. Circuit status provides you the state on the Microsoft side. Alright, so that's the end of the circuit or ExpressRoute circuit creation. The next step is you can watch channel and video on how to provision your service provider connection. So in this lab exercise, I'm going to demonstrate how you can create load balancer solution in Azure. We're going to particularly see an example on how you can use a load balancer to route the traffic on non-HTTPS solutions. I hope you find this information useful. So the first task we are going to perform is to go and create and configure the Azure load balancer. So before I do that, I just want to quickly highlight what is a public load balancer. So the key difference is that with a public load balancer, the front end is accessed via a public IP address, and you test connectivity from a host which is located outside of your virtual network. Whereas an internal load balancer, the front-end IP is a private IP address which is inside your virtual network, and you test this connectivity from the host inside the same network. This is the kind of environment what we are going to simulate in this exercise. So first task, what we're going to do is we're going to create a virtual network, and then we'll create the backend server and the load balancer, and we will create the load balancer resources, and finally we will test the load balancer. So let's go and start this exercise. The first step what we're going to perform is to create a virtual network. So to create a virtual network, click on create a resource and type in virtual networks and select the virtual network. Click on create to create your virtual network. Make sure you select the right subscription. Under resource group, we don't have any resource group to select, so I'm going to create a brand new one. So I'm going to call it as internal load balancer resource group and click on OK. Give a name for your virtual network. I'm going to call it internal load balance VNet. For the region, I'm going to retain East US itself and click on IP address to go to the next page. By default, the allocated address space is 10.0.0.0/16. I'm going to change it to 10.1.0.0/16. Because it's a brand new VNet, we will not have any subnet. So I'm going to click on add subnet and create a brand new subnet. So I'm going to name the subnet. The first subnet I'm going to name is my backend subnet. And the subnet address range I'm going to give is 10.1.0.0/24. Leave the rest of the option to default and click add. So we have one subnet added. So next task I'm going to do is I'm going to add one more subnet. So go back and click on add subnet again. Give a name for your subnet. So this time I'm going to call it as my front end subnet. The IP address range I'm going to give this time is 10.1.2.0/24. 2024 and click on add. After completing that step, click on security. Under Bastion host, click on enable. So we're going to enable Bastion access to this VNet and give a name. I'm going to call it my Bastion host. Under address space, give 10.1.1.0/24. And under public IP, click on create new. Give a name for your Bastion public IP. I'm going to call it as my Bastion IP and click OK. Leave the rest of the details to default like firewall and DDoS protection and click on review and create. After the validation, click on create. The validation has been completed, so click on create. So this wouldn't take much time. Mostly it would take around a minute or so to create the virtual network and the subnets, and that's about it. Then we can continue the exercise later. Alright, so the deployment of the virtual network has been completed. You can click on go to resource. So the internal load balancer VNet has been created. You can check the address space by going into address space. So this is what we have assigned, and click on subnet. You can see all the subnets we created, including the Bastion subnet. Now that we have completed the virtual network, in the next task, we are going to create the backend servers. Let's go and do that. So to quickly deploy all the necessary virtual machines, I'm going to deploy a script or an ARM template so that we don't have to waste the time of going through the GUI and installing all these servers and the roles. So it would take ideally 5 to 10 minutes for me to create all these 3 virtual machines. So we don't have to wait for this step to create the next step. The next task, what we are going to do is we are going to create the load balancer. So that is what we are going to do right now. So while this is happening, I can quickly go to the virtual machines tab and see if any task is running. Nothing is visible at this point. So we can come back to this later point in time to verify if that is happening or not. So to create the load balancer, go to your home page and click on create a resource. In the search box, type in load balancer. Under the results page, select the load balancer which says Microsoft. So this one is from Microsoft. I'm going to select this load balancer and click on create. So to create the load balancer, I'm going to retain the same subscription. Resource group, I'm going to pick the one which we created just before for creating the VNet. So the one which we created is internal load balancer resource group. Click that. Under name for the load balancer, I'm going to give my internal load balancer. Under region, I'm going to retain East US because that's where I created other resources. The SKU type, we have basic, gateway, and standard. I'm going to retain standard. The type of the load balancer, instead of public, because this is an internal load balancer we are creating, so this is an important step. So make sure you select internal load balancer. Under tier, I'm going to retain regional and click on next front-end IP configuration to continue further. We don't have any front-end IP configured, so click on add a front-end IP configuration. Under name, give a name for your front-end IP. So I'm going to call it as load balancer front-end. Virtual network is by default selected. Okay, that's the VNet we have in that particular region. So under subnet, make sure you go and select my front-end IP address. So because we are creating a load balancer front end, so select that. Under assignment type, retain dynamic. We don't want static on this. And you have various availability zones. So I'm going to select zone redundant and click on add. While that is happening, our resources has been created or it started processing the resources. So we can go back and check after finishing this exercise. Now let's go and click on review plus create and click on create. So this is how you create your load balancer. So while that is happening, let's go back to the Azure homepage and click on virtual machines. Click on virtual machines. Yeah, you should be able to see now we have the first virtual machine which is created and the status is running. So right now what the script is doing is it is deploying the second virtual machine. So after that, it is going to deploy the third virtual machine. So we need ideally 3 virtual machines to complete the whole task of testing. In the meantime, the deployment of our load balancer is complete. So I'm going to go and check the load balancer. So click on go to resource. So this is the load balancer we just created. So you can click on front end IP configuration to see the IP we configured for the front end of the load balancer. Now in this task, what we're going to do is we're going to create the backend pool and we're going to add VMs to the backend pool. So within the load balancer we created, under settings, click on backend pools. So we don't have anything in the backend pool at the moment. So go and click on add. Give a name for your backend pool. I'm going to call it as my backend pool. The virtual network is selected by default because that is what we wanted. Under virtual machines, we have to come here and click on add to add virtual machine. So right now I only have 2 virtual machines configured. So I have to wait for some more time so that I can see the third virtual machine, which is currently being under deployment. So as you can see here, the script is executing. So right now it just finished installing the first one. The second one is at the creating stage, and after finishing this, the third one would run. So we have to wait for that to complete to go to the next step. So I'm going to pause the video. We'll come back to this step later. Alright, so our second virtual machine is also deployed. As you can see in the script, it is successfully deployed. And we have the second NIC is also configured. Now it is running the third script, which is to deploy the third virtual machine. So if I go to another Azure portal and click on virtual machines, I can see that my second virtual machine is also created and the status is running So now we are waiting for the third virtual machine. So let's quickly check the status of the third virtual machine. I'm going to quickly do a refresh. Yep, we can see that our third virtual machine is also created and the status is running. Now, if we go back to the portal, I'm going to just quickly minimize the Cloud Shell. And if we try to add virtual machine now here by clicking on add on the backend pool, we should be able to see the third one. All right, so I'm going to quickly do a refresh. So I'm going to quickly start over the backend pool process. I'm going to cancel this. We're going to do it one more time. So click on add to add the backend pool. Give a name to your backend pool. I'm going to call it as my backend pool. And under virtual machine, click on add. Yep, you can see all 3 virtual machines at the moment. So select all of these virtual machines to add it to the backend pool, VM1, VM2, and VM3, and click on add. Now it is validating. After validation, we will see all these virtual machines will be added to the backend pool. Alright, so the deployment of this backend pool is completed. So I'm going to close this notification. And here you can see that all 3 virtual machines are added and the status is running on all 3 virtual machines. Now let's go and create a health probe. So the load balancer monitors the status of your app with a health probe. And the health probes adds or removes VMs from the load balancer based on their response to the health checks. So let me show you how you can create the health probe. So under your load balancer, go under settings and click on health probes. So we don't have any health probe yet. So click on add. Give a name for your health probe. I'm going to call it as my health probe. Under protocol, we are going to select HTTP and port 80. Path we are going to give /interval every 15 minutes. It totally depends on your use case scenario. An unhealthy threshold, I'm going to keep it as 2 consecutive failures and click on add. So now it is deploying the health probe and we have a health probe which is running within our load balancer. Next resource what we're going to create within the load balancer is the load balancer rule. A load balancer rule is used to define how traffic is distributed to the virtual machines. And you can define the front-end IP configuration for the incoming traffic and the back-end IP pool to receive the traffic. The source and destination port are defined in that rule. So let's go and create the load balancer rule. So within your load balancer, under settings, click on load balancer rules and click on add. Give a name for your load balancer rule. So I'm going to call it as my HTTP rule. Version type as IP version 4 because that's what we have. Front-end IP address, select the front-end. So we created the load balancer front end. So this is the IP address, and select the backend pool. So my backend pool, scroll down under protocol, select TCP, and port, we're going to monitor 80, and the backend port is also 80. Under health prob, select my health prob, which we just now created. Session persistence is none. Ideal timeout, I'm going to keep 15 minutes, and rest, both of these values I'm going to retain as default, TCP reset and floating IP, and click on add. All right, so our rule is also created. So all of the resources which is required for the load balancer is created. So we completed the task of creating the backend server, we created the load balancer, and then we created all the load balancer resources like health prob and a load balancer rule. Now in the next task, we are going to test the load balancer. Let's go and do that. So to test the load balancer, first step, what we're going to do is we're going to create a test virtual machine. So I'm going to go to Azure portal and click on go to resources and click on virtual machine and create a virtual machine. Make sure you select the right subscription. I'm going to choose all the resources to go inside the subscription we just created. Sorry, resource group I created, which is internal load balancer resource group. Give a name for your virtual machine. I'm going to call it as my test virtual machine. Region, I'm going to retain East US because that's where all of my resources are. Availabilities option, because it's a test environment, I'm going to choose no infrastructure needed. Security, because I'm going to delete it, I'm going to leave it as standard. Under image, I'm going to select Windows Server 2019 Data Center Gen 2. Under the size, so I'm going to pick DS2v3. Give an administrative username and a root password to log into the virtual machine. Under inbound ports, I'm going to select RDP because we want to log in via RDP. Click on disk. I'm going to keep the premium disk for this exercise and click on networking. By default, the virtual network is picked up as internal load balancer VNet. Under subnet, I'm going to keep it as my backend subnet. Public IP address, I'm going to change to none. Scroll down under NIC security group, click on advanced. Under network security group, I'm going to select my NSG and scroll down. You have an option to place this virtual machine in the backend pool of an existing Azure load balancer solution. So we are not going to do that. So I'm going to keep it none and click on review and create. Looks like our validation is failed. So we have to change the virtual machine, I guess. So let me quickly check the details. So I'm going to go back and change the virtual machine size because I don't have enough quotas in this subscription. So I'm going to pick one, which it should allow me DS1v2 and click on review and create. Yep, validation has been passed. So click on create. So this is going to take at least 2 to 3 minutes. So I'm going to come back. I'm going to pause the video. We are going to come back after completing this step. All right. So our deployment of this virtual machine is being completed. So click on go to resource. So this is my test VM and the status is running. Now let's go and complete this exercise. So now what we're going to do is we're going to connect to this test VM and we're going to test the load balancer. So let's go back to the home page and click on our load balancer. So the load balancer, what we created is my internal load balancer. Under the overview page, we are going to copy the private IP address of this load balancer. To see the private IP address, so click on see more. So this is where you can copy the private IP address of this internal load balancer. Now go back to home. Let's go to our test virtual machine we just created. This is called my test virtual machine. Under the overview, click on connect. So this time instead of RDP, we are going to retain Bastion. Put the username what we given to that virtual machine, which is test user, and the password for that virtual machine, and click on connect. So the pop-up blocker is blocking me, so I'm going to allow the pop-up. Click on done, and I'm going to connect one more time. I'm going to select yes. All right, so now we have connected to our test virtual machine via Bastion. So let's go to Internet Explorer and try to test our load balancer is working or not. Accept the recommended settings, and on the internet browser, I'm going to paste the IP address of the load balancer. We just copied. Oh, it's not working. So I'm going to go back to the Azure portal, go home, my internal load balancer, what's the IP address? Click on see more. It's 10.1.2.4. So go back to my test VM. I'm going to type in 10.1.2.4. All right. So you can see that the machine is returning. So our load balance is definitely working. Now it is pointing to my virtual machine 1. Because we have 3 virtual machines in the load balancer. If you go to the backend pool, let me quickly show you, we have 3 virtual machines. So right now, we are getting the value from the virtual machine 1. And if I go back and refresh a couple of times, maybe we will get the response from virtual machine 2. Now it is responding from virtual machine 2. After some time, if you do keep on refreshing, you might get response from VM3 as well. So let me zoom in and let's do one more refresh now. Yep. So now the VM1 is changed to VM3. So that's how you create a load balancer and test if your load balancer is working. So what I'm going to do right now, I'm going to delete all the resources we created so it is not going to burn my existing Azure credit. So in this lab exercise, we are going to create a couple of web applications and we are going to create a traffic manager profile and see how the traffic manager can be used to route the traffic between these web applications. Even if one web application is down, how the traffic manager can reroute the traffic to another one which is available. So let's go and start the lab. In this exercise, we are going to create a traffic manager profile to deliver high availability for the company called Contoso Limited Organization's web application. We're going to create 2 instances of the web application and deploy it in 2 different regions. One in East US and another one in West Europe. The East US region will act as the primary endpoint for the traffic manager and the West Europe region will act as the failover endpoint. And the way we are going to create the traffic manager profile is based on the endpoint priority. So this profile will direct user traffic to the primary site running the web application. First step, let's go and create web applications. On your Azure portal, click on create a resource and search for web app and select the web app which is provided by Microsoft and click on create. Make sure you select the right subscription. You can either choose an existing resource group or create a brand new one. We're going to create a brand new resource group. We're going to call it as Contoso Resource Group for Traffic Manager 1. Click OK. Give a name for your web application. I'm going to call Contoso Web Application East US 321. Under the publishing type, make sure you select code. Under runtime stack, we're going to select ASP version 4.8. Operating system, we'll choose Windows. Under region, we're going to pick East US. Scroll down. Under app service plan, click on create new and give a name for your web application plan. So I'm going to call it as Contoso App Service Plan East US and click OK. Under the SKUs and size, click on change size. I'm going to retain the production one, but it's the standard one, which is S1 plan, and click on apply. Click next to go to the deployment tab. And we are not making any changes here this time. Click on networking. Again, no changes in the networking tab. Click on monitoring. Under monitoring tab, disable the application insights and click on review and create. After the validation, click on create. So now this is going to create the web application. It will ideally take 1 to 2 minutes to complete this whole process. While this is happening, let's go and create another web application in the West Europe region for our next test to create the traffic manager profile. So I'm going to go back to the home page, click on create resource. Again, I'm going to repeat the whole process. Web app, click on the web app and click on create. So our first web application is deployed. I'm going to not click on go to resource at the moment because we're going to create one more and we'll go and check the web application. So go and create another resource group. This time name it as Contoso Resource Group for Traffic Manager 2. Click OK. Give a name to the web app. So the last one we called as Contoso Web App East US. So this time it is West Europe. I'm going to call it Contoso Web App West Europe 321. Publishing code is code. Runtime stack ASP.NET version 4.8. Windows. Under region, we're going to pick West Europe. Give a name for the app service plan. I'm going to create a new app service plan and I'm going to call it Contoso App Service Plan for West Europe. Click OK. I'm going to change the size to standard again. Under production, go and pick the standard plan, click apply. Next, deployment, we are not making any changes. Networking, we are not making any changes. Under monitoring, I'm going to turn off the application insights monitoring and click on review and create and click on create. All right, so now while the deployment is happening, let's go back to the home page, and on the global search box, type in app service, select app services. We will be able to see both the app services we created just now. So the first one is created. You can click on it and you can go to the overview tab and you can see that this is running and this is the URL for this web application. So let's go back to our app services. Let's wait for the other one to get created as well. In the meantime, if you want to know if the web application or the web app we created is running, so you can go to the overview pane and click on this URL, and by default this would be running a sample website because we haven't deployed any code in it. But this is to make sure that this is running, this web application is running at the moment. I'm going to go back, go to app services. Let's hit refresh. All right, so now we have both of our web application created. Make sure that one is created in East Europe. One is created in East US, another one is in West Europe, so that we can test the traffic manager. So now let's go and create the traffic manager profile. So go back to your home page and click on create a resource and search for traffic manager profile. Hit enter and create traffic manager profile. Under the name of the profile, give a name. I'm going to call it Contoso Traffic Manager Profile 321. Under routing method, not the performance, we're going to use priority. Make sure you select the right subscription. Resource group, I'm going to keep it under Contoso Resource Group Traffic Manager 1. And I'm going to place it in East US and hit create. So now this is deploying the traffic manager profile. It would ideally complete the step in about a minute. So it's completed. So let's click on go to resource to see the traffic manager we just created. All right, so that is done. Now the next task is we are going to add endpoints to this traffic manager. To do that, go under settings and click on endpoints. So we don't have any endpoint at the moment. So click on add endpoint. Under the type, select Azure endpoint. Give a name. So I'm going to call it my primary endpoint. Under target resource type, select app service, and target resource, make sure you select the East US one and priority 1. Click on add. So our first endpoint is added. So while that is saving, let's click on add one more time and add our second endpoint. Again, Azure endpoint, give a name. This time we are adding the failover endpoint. So that is the second one. So add my failover endpoint. Target resource type, app service again. Choose the app service. This time it is West Europe 1. Priority 2 and click on add. All right. So the setting, let me quickly explain. The setting or the priority 2 means that the traffic will route to the failover endpoint if the configured primary endpoint becomes unhealthy. Let's go back to the all right, so I'm not going to modify any changes. So we need to make sure that both are online. So right now it is showing our primary one is online and the secondary one is checking the endpoint. So the priority also, we need to make sure that both are set right. So the primary one should be 1 and the secondary or the failover point should be 2. So I'm going to quickly do one more refresh and we need to wait until the failover endpoint change to online. All right, so both of our endpoints are online. Now we have completed the step 3, which is adding the traffic manager endpoint. The last step is to test the traffic manager profile. Let's go and do that. So to do that, go to your traffic manager profile and click on overview and copy your DNS name. I'm going to open another tab and paste the DNS, which we copied from the traffic manager, and hit enter. All right, so as you can see that the web app's default website should be displayed. So we can see the default website is visible. If for some reason you get 404 website not found message, disable the profile from the traffic manager and then enable profile and refresh the page. So sometimes it will take some time to work. So right now, all the traffic is being sent to the primary endpoint because it is set to primary one, which is, let me go back. So if you go back to the endpoint, all the traffic will direct to the primary endpoint because the priority is set to 1. So to test the failover is working, so what we are going to do is we are going to select the primary endpoint and we're going to disable it and click on save. So for some reason, if the primary endpoint is not working or the website is down for whatever reason, because we have the traffic manager profile set to go to the next one or the failover one, it should ideally reroute the traffic back to the second one. Now let's go back to the traffic manager profile, hit refresh. You can see that the status is disabled right now. Now I'm gonna close this window. Let's go back to the traffic manager, copy the DNS one more time, and I'm gonna go to another tab and let's see if we are able to connect to the default website. Right. So again, the web app is running. So we are able to connect to the web app and the web app is responding. Even though the primary endpoint is not available, the traffic is routed to the failover endpoint, which allows the website to still function. So that was a quick example on how to use traffic manager profile to reroute the traffic and kind of use it as a load balancer to reroute the traffic using the profile mechanism. So in this lab exercise, we are going to look into Azure Application Gateway. So we're going to create a couple of virtual machines and we're going to add it to the backend pool and we're going to test the Azure Application Gateway. So let's go and start the lab. All right, so in this exercise, we are going to use Azure Portal to create an application gateway. And then we are going to test it to make sure it works correctly. So the application gateway directs application web traffic to a specific resource in a backend pool. And then we are going to assign listeners to the port, create some rules, and add resources to the backend pool. So without wasting any more time, let's go and start creating an application gateway. To create one, go to your Azure portal and search for application gateways and select. So we don't have one at the moment, so I'm going to create one by clicking on create. Make sure you select the right subscription. We can either create a new resource group or select an existing one. Since we don't have one, I'm going to create new. I'm going to call this resource group Contoso Resource Group. Click OK. Give a name for your application gateway. I'm going to call it as Contoso App Gateway. Pick a region where you want to deploy. I'm going to retain it in East US. Under tier, I'm going to keep it as standard version 2. We have an option to convert this as a web application firewall as well. So in this exercise, we're going to keep it as standard. I don't want to enable auto scaling now. I'm going to select no. Instance count, I'm going to keep it as 1. Availability zone, for this exercise, I'm going to keep it none. So if you want to enable it for HTTP2, you can enable it as well. So I'm going to keep it disabled. The next task is to create or select a network. So since we don't have one, I'm going to click on create a new virtual network. Give a name for your virtual network. I'm going to call it as Contoso VNet. The default address range is 10.0.0.0/16. I'm going to keep it as it is. And we have a default subnet, which is 10.0.0.0/24. I'm going to change the default to application gateway subnet. And I'm going to add one more subnet. This one, I'm going to call it as backend subnet. And the IP address range I'm going to give is 10.0.1.0/24. So now we created a VNet, and within that VNet, we have two subnet. One is application gateway subnet and another one is backend subnet. Click OK. So within front end, make sure you select the type as public IP address as the type for the front end IP address type. And under public IP address, click on add new and give a name for your public IP address. I'm going to call it as application gateway public IP address. Click OK. Next, click on backends. So we don't have any backend yet. So click on add backend pool. Give a name for your backend and make sure you select yes to add backend pool without targets. Click on add. Next, click on configuration. So under the configuration tab, this is where we are going to connect the front end and backend pool we created using the routing table. So under the routing rules, click on add a routing rule. Give a rule name. So I'm going to call it as routing rule. Under listener name, I'm going to call it listener. Front end IP, I'm going to set it as public. Make sure the protocol HTTP is selected. Port is 80. Listener type is basic and error page URL, no. Next to listener is the backend target. So click on backend targets. Target type, make sure you select the backend pool and select the backend target as backend pool. Under HTTP settings, we don't have one, so click on add new. I'm going to give the name for the HTTP settings, HTTP setting, and the backend port is 80 and click on add. So now we have added the listener rule and the backend targets. Click on add. Now we have the front end, backend pool, and we have the routing table to connect both. Click on next. For the tags, we are not providing any tags. Click on review and create. After the validation, click on create. So Azure would take at least a few minutes, like 4 to 5 minutes, to create your first application gateway. And we will wait for this deployment to finish before starting the next step. The next step is we are going to create a virtual machine. Alright, so our deployment is been completed. Click on go to resource to go check your application gateway. So we are in the Contoso resource group we created. Within that, we can see that there is a virtual network, the public IP address, and the Contoso application gateway created. So we will come back to this application gateway later. In the next task, we're going to create virtual machines, and then we will go and add the backend servers to the backend pool. So let's go and do that. So for the ease of deployment, just to get the virtual machine for this environment, I'm going to use some script. It's an ARM template that I'm going to deploy it via Cloud Shell, so we get our virtual machine for our testing. So I'm going to execute the command to install my virtual machine. So if I go back to the virtual machine, you will soon see a virtual machine here under creation status. So let's hit refresh. You can see that there is a backend virtual machine which is in the creating stage, and we have a backend virtual machine 2 which is also in the stage of creating. So we have to wait until it says it's running. Let's do a refresh one more time. Alright, so both the virtual machine is been successfully created and both are running. The next task is we are going to add the backend servers to the backend pool. Let's go back to the home page, go to all services, go to resource group, and pick the resource group where we created the application gateway, and make sure you select the application gateway. I'm going to sort it by type and select the Contoso app gateway. On the left hand side under settings, click on backend pools and select the backend pool. Under the target type, select virtual machines and make sure you select the backend VMs we just created. So I'm going to select the first one, which is VM2, and again select virtual machine and select the VM1 and hit on save. It is initializing the deployment to make sure that both of our targets are added to the backend pool. So now we have to wait for the deployment to complete before to proceed to the next step. The deployment is still going on. Alright, so it is complete now. So now our last step is to test the application gateway. Let's go and do that. So let's go back to our application gateway and click on overview. Although IIS isn't required to create the application gateway, I have installed IIS on this virtual machine, so it helps us to verify that the application gateway is working. So what we're going to do is we're going to use the front-end IP address to make sure we are able to connect to the backend virtual machines. Go to the front-end public IP address and copy it. Go to another page or another tab and try to browse. So as you can see that it is now connected to the backend virtual machine. We got a response back from the virtual machines. This is a confirmation that the application gateway is able to connect to the backend pool, which is VM1 or VM2. So if we hit a refresh multiple times, since we have two virtual machines, sometimes the connection can come from virtual machine 1 as well. So right now it is picking the connection from virtual machine 2. Now it is changed to virtual machine 1. Congratulations, now we have configured and tested the Azure application gateway. So in this lab exercise, we are going to see Azure front door in action. So we're going to create two web applications and we are going to create an Azure front door for this application. And we're going to test how Azure front door is going to be helpful for your application. So let's go and start the lab. So in this exercise, we are going to set up an Azure front door configuration that pools two instances of a web application that runs in different Azure regions. This configuration is going to direct traffic to the nearest site that runs the application. And Azure Front Door continuously monitors the web application. So we are going to see the automatic failover to the next available site when the nearest site is unavailable. So this is an example diagram what we are going to simulate just now using this lab exercise. The high-level tasks we are going to perform in this lab include creating 2 instances of a web app, create a front door for the application which is running on this web app, and we are going to see the Azure front door in action. So let's get started. First, go ahead and create 2 instances of a web app. Use the global search box and type in app services and select app services and click on create. We're going to create a new resource group called Contoso resource group. Give a name for your web app. I'm going to call it as web app Contoso-321. Under the publish, select code, runtime stack. We're going to select .NET 3.1, operating system Windows, region. The first one we are going to pick Central US. Scroll down. Under app service plan, click on create a new app service plan. And I'm going to call it as my app service plan Central US and click OK. Under size, click on change size. Under production, I'm going to pick standard. Click apply and hit on review and create. After the validation, this is going to create our first app service web app. Click on create. So while this is happening, I'm going to create one more. So I'm going to go back to app services. So while this is creating, I'm going to click on create another one. Again, I'm going to keep the existing subscription. This time I'm going to choose the same resource group. Scroll down and I'm going to call this web app Contoso-3212. Under publish, select code, runtime stack, .NET Core 3.1 LTS, Windows operating system, but in the region, we're going to pick a different region. So this time we're going to pick East US. Scroll down to find the app service plan. I'm going to create a new app service plan. This time I'm going to call it as app service plan East US. The other one was Central US. So click OK. As you can see, our other deployment for the app service is completed. So we'll go back to that later. Click on change the SKU and size. I'm going to pick production standard S1, hit apply and click on review and create. So our second deployment will just now start after the validation. So click on create. All right. So now while that is happening, let's go back to our app service plan. I'm going to go back to home page, click on app services. I'm going to hit refresh. As you can see that the first web application is being created. It's created in Central US and it is running. So second deployment is in progress. So soon we will see another one just below this, which will be running in East US. All right. So looks like our deployment is complete. I'm not going to go to resource. I'm going to simply refresh this page. All right. So looks like both of our app services are created and both are running in 2 different regions. One in Central US and another one in East US. Now that the first task is completed, let's go and do the second task, which is create a front door for your application. So let's head back to the Azure homepage. In the global search box, type in front door. So due to the frequent Azure changes, you may need to select the Azure front door or Azure front door and CDN profiles. So sometimes it used to be Azure front door. Now it is known as Azure front door and CDN profile. So select that. We don't have any Azure front door and CDN profiles. So hit plus to create a brand new one. So in our case, we are not going to create the Azure front door offering, the first one. We are going to explore other offerings and click continue. So make sure you select the default subscription. Resource group, we are going to select the Contoso resource group we've been using. And the location by default, it picked up Central US. That is fine. And click on configuration. So under the configuration tab, first click on front end domains and click on this plus icon and give a host name. I'm going to call it as Contoso-frontend321. And I'm going to leave all other values as default and click on add. Next, we're going to add backend pool. So click on add, give a name and click on add backend. Under backend host type, make sure you select app service. The rest of the values are populated by default. Under the backend host name, we need to make sure that we select the first web app. So our first web app is 321 and our second web app is 3212. So I'm going to select the 321 as the first one and leave all other values as default like HTTP port, etc. So click on add, and we are going to add one more backend. So make sure you click on add a backend one more time. Here again, one more time, click on add app service. This time, instead of the first app service, I'm going to select the second app service and leave all other fields as default and click on add to complete the process. So now we have added the front end and domains and backend pools. The next step is to complete the routing table. So hit on add on the routing table. Give a name for your routing table. I'm going to call it as location rule. Leave the rest of the values to default like accepted protocol as HTTP and HTTPS and hit on add. So our front-end configuration is completed. So we have our domain, backend pools, and the routing table. Now hit review and create. After the validation, click on create. Alright, so our deployment is completed. So click on go to resource to just verify if you want to verify something about the deployment. Now that we have completed the task 2, the final task is to verify and view the front door in action. So let's go and do that. So let's go to all of our resources and find the front door we just created. So click on the front door we just created, and under the overview pane, make sure you find the front end host address and copy that. So go to another tab, paste the address which you copied. So now this is automatically routed to the nearest server to you from the specified servers in the backend pool. So now we had, if you remember, in the backend pool, we have 2 servers configured. So if you remember in the exercise, we created 2 web app and we have added both of these web app in the backend server. So let's go and find out if this is working if we stop one of these server. So I'm going to go back to the Azure portal, go to your app services. As you can see that we have both of these app services running, and both of these app services are added to the backend pool. So what we are going to do is we are going to select one of it and we are going to hit stop and click on yes. So one of our web services is stopped. So let me quickly refresh. It is still running, still running. Let's hit refresh one more time. All right, so now it's saying that it stopped. So let's go back to the front door, or let's go back to the portal one more time and see if the front door is instantly failed back into another global service. So I'm going to refresh it. We see that error message, but there may be a slight delay while the web app stops. So we just need to hit refresh because it immediately picks up the results. Oh yeah, it's came back up. So we only see a momentary glitch. So one of our services, one of the app services is running in the central US is stopped, but the front door is configured in such a way that it should automatically fail over to the another one when it detects that this one is stopped running. So the central US is stopped running. We can still access the web application in the backend because it picked up one which is running in the East US. All right, so congratulations. Now you have learned the use case scenario of Azure Front Door and Azure Front Door Service. So in this lab exercise, we are going to see Azure DDoS protection in action. So we're going to create an Azure DDoS protection plan, and we are going to enable this DDoS protection on a network, enable telemetry, and we are going to do an actual DDoS attack on this Azure environment to see if we can find out any proof of DDoS attack happened within our environment. So let's go and start this lab. As a cloud engineer or a network engineer, it's your responsibility to protect your company's workload from any sort of DDoS attack. So in this exercise, I'm going to teach you how to create Azure DDoS protection to protect your workload. Some of the tasks we are going to perform in this exercise include creating a resource group, creating a DDoS protection, and enable the DDoS protection on your virtual network, and configuring the telemetry, diagnostic logs, and alerts, etc. So let's go and start our lab. So first couple of things what we are going to do is we're going to create a resource group, virtual network, and we're going to create and configure the DDoS protection. So let's start with creating a resource group. So click on resource groups. So we don't have anything at the moment. So click on create to create our first resource group. I'm going to call this resource group my resource group. And the region I'm going to pick East US. And click on review and create. Creating a resource group won't take any time. So it immediately creates the resource group. The next, what we're going to do is we're going to create the DDoS protection. So go back to your home page and on the global search box, type in DDoS protection plan and select the DDoS protection plan. Click on create. Make sure you select the right subscription. Resource group, I'm going to select the one which we just now created, which is my resource group. Give an instance name for your DDoS protection plan. I'm going to call it as my DDoS protection plan. And I'm going to create that within East US itself. And click on review and create. After the validation, click on create. Our deployment is in progress. And we successfully completed the deployment of the DDoS protection plan. Cool, let's click on go to resource to see your DDoS protection plan. We'll come back to this later. Now that we have completed task 1 and task 2, the next task is to enable the DDoS protection on a new virtual network. For that, we are going to create a brand new virtual network now. Go to the Azure homepage, click on create a resource and type in virtual network and select virtual network and click on create. Select the right resource group. We're going to retain everything under my resource group. Give a name for your first virtual network. I'm going to call it as my virtual network. Click next to the IP address. We can see that there is a by default, there is an address space which is 10.0.0.0/16. If you do want to modify it, you can modify it here. By default, there is a default subnet as well. You can rename it or you can create additional subnets within this address space. Now let's go to security. Under security, let's keep the Bastion host as default. Under DDoS protection standard, click on enable and under the DDoS protection plan, choose the plan which we just now created and click on review and create. This goes through a validation and after validation, click on create. Again, this wouldn't take much time either. Within a minute or so, your virtual network with the subnet enabled with the DDoS protection will be created. Alright, so the deployment is successfully completed. Click on go to resource to see your virtual network you created. Click on address space to see your address space. Subnet to see the default subnet. Under DDoS protection, you can see that it is applied with the DDoS plan which we selected. The next task we are going to perform is to configure the DDoS telemetry. To enable DDoS telemetry, we need to first create a public IP address. So first go to create a resource and type in public IP and hit enter. And select public IP address Microsoft and click on create. So under IP version, make sure you choose IPv4. SKU instead of standard, we are changing it to basic. Tier is irrelevant. Under name, give a name for your public IP address. So I'm going to give it my public IP address. Under IP address assignment, make sure you select static. Scroll down and under DNS name label, I'm going to call it my public DNS 321. Make sure you select the right subscription, choose the right resource group. I'm going to choose my resource group and we're going to retain the location as East US itself and click on create. So the deployment of public IP is been going on. It wouldn't take anyway more than 1 minute or so. Alright, so the public IP address has been created. You can click on go to resource to see the public IP address. Under configuration, you can see the public IP address and we make sure that we selected static while we creating the address. The next step is we need to go back to our DDoS protection plan. So I'm going to select the DDoS protection plan we created. On the left hand side, under monitoring, click on metrics and on the scope, select public IP address and apply. In the metrics box, scroll down and select inbound packets dropped DDoS. And on the aggression box, select max. And I'm going to save it. If you want, you can pin it to the dashboard as well. Now that we have completed the DDoS telemetry configuration, we will next go and create the DDoS diagnostic logs. To configure the DDoS diagnostic logs, let's go back to all resources and select the public IP address we created. And on the left hand side, under monitoring tab, select diagnostic settings. We don't have anything at the moment, so click on add diagnostic setting. First provide a name, so I'm going to call it as my diagnostic setting. Under categories, I'm going to select all. So we want to check details of DDoS protection notification, mitigation flow logs, and mitigation reports. Under metric, I'm going to select all metrics. Under the destination details, I'm going to send to log analytics workspace. And if you want to send this to the log analytics, you would select this option to send it to the log analytics. You have other option to select it. You can either send it to storage account, or if you have an event hub or another partner solution like a webhooks solution, you can send it to that as well. So I'm going to discard now. We are not going to send it, but this is how you can configure the DDoS diagnostic monitoring settings. Now let me show how you can set up the alerts. To configure the DDoS alerts, first step what we are going to do is we are going to create a brand new virtual machine, and within the virtual machine we are going to assign the public IP address we created, and we are going to create the alert there. So let's go and do that. So to create a virtual machine, go and click on either create a new resource or click on virtual machines. As of now we don't have any, so click on create a brand new virtual machine. Select the right subscription. Make sure you choose the right resource group. I'm going to keep it under my resource group. Give a name for your virtual machine. I'm going to call it as my virtual machine. Place it in whichever region closest to you. I'm going to keep it in East US. Availability zone, because it's a test environment, I'm going to choose no infrastructure redundancy required. Under image, I'm going to keep the Ubuntu server itself. Under size, click on all sizes. I'm going to pick a smaller configuration machine. So I'm going to type in B1. I'm going to select B1LS and click on select. Authentication type as SSH public key. The username is already given, which is Azure user. If you want to change it, you can change it. For the SSH public key source, I'm going to put it as generate a new key pair. Under the key pair name, I'm going to give my virtual machine -SSH key. You can leave rest of the values as default and click on review create. After validation, click on create. So I'm going to download the private key just in case if I need to use it. So I'm going to keep it. And the deployment of virtual machine is in progress now. It would take, I think, couple of minutes to complete deployment of a virtual machine. So we can go to the home page and click on virtual machines and refresh this page. We will be quite soon, we'll be able to see the status of this virtual machine deployment. All right, so our deployment has been completed. Click on go to resource to go to your newly created virtual machine. Now we are going to assign public IP address to the virtual machine. So to do that, under settings, click on networking, and next to your network interface, click on your network interface. Under the settings, click on IP configurations and select the IP config. So within the public IP address, go to the drop down and select my public IP address. This is what we created for the DDoS protection. So select that and go and click on save. So right now what we have done is we created a virtual machine. Instead of using the default public IP address given for the virtual machine, we modified it with the public IP address we created, and we have added this public IP address before to test the DDoS telemetry, things like that. Now that is happening. The next task we're going to perform is we're going to configure the DDoS alerts. So the network interface has been saved. So let's go back to the home page, go to resource groups and select my resource group. What we're going to do is we're going to select the my DDoS protection plan. Click on that. On the left hand side, under monitoring, this time instead of metric, we're going to select alerts. We don't have any alert yet, so we're going to create a new alert rule. Click on alert rule. Under create alert rule, first click on select scope. In the filter by resource type, select the drop down and find the public IP. So I'm going to select public IP address and make sure you select my public IP address, which is what we created for the DDoS protection, and click on done. Next, click on signal. Under selected signal, I'm going to select under DDoS attack or not and select that. and scroll down under operator, provide the threshold value to 1. So greater than or maximum threshold value is 1. Click on done. We don't have to do anything on the actions page. Go to the details tab, give a name for the alert. I'm gonna call my DDoS alert and click on review and create and click on create. Alright, so the alert is created as well. Now we need to go and test the service. So what we're going to do now is we're going to submit a DDoS service request to run a DDoS attack. So to do that, you can go to breakingpoint.cloud. So I don't have an account yet, so I'm going to create one. So I'm creating a brand new account to test this DDoS attack. You can also do that by going into breakingpoint.cloud and you can create a trial account to test this. Alright, so my account is all set and ready to go. I'm going to click on start trial. So before we start the DDoS attack, so I'm going to open another Azure portal and we're going to open the metric this time. We're going to select inbound packets dropped by DDoS and aggregation is max. Alright, let's go back to the breaking point. So we need to provide the target IP address. So to find the target IP address, I'm going to go back to my portal again, click on the public IP address and copy the public IP address. So you can find the public IP address under overview, and within the overview tab you can find the IP address. And I'm going to go back to the breaking point, the target IP as public IP address, port 443, DNS flood as the DNS profile, test size is 100K, 60 Mbps and 2 source IPs. Test duration, I'm going to keep it 10 minutes. Let's see if we can keep the test size as 200 kbps. Alright, so I'm gonna trigger the test. So it may take up to 10 minutes to see any sort of activity. Alright, so it looks like we have to provide our subscription as well. Enter your subscription ID. Oh, this is new. So I'm gonna go back to the portal and find the subscription ID. Let's copy the subscription ID and let's go back to the Breaking Point website and let's paste it and click on add subscription. Okay, looks like we need to provide admin consent, so let's provide that. Accept. I should have done this as the first step, the authorization to the Breaking Point. Alright, so looks like our subscription is authorized. I'm gonna close this. I have to redo this again, so I'm gonna go find the public IP address one more time, copy the public IP address, go back to the breaking point, provide that as the target, change the port to 443, DDoS profile as DNS flood, test size I'm going to keep it 200K, hope it works, and test duration is 10 minutes. So click on start test. Alright, so I can't run this because it exceeded the 5 GB trial, so I'm gonna change it to 100 kbps. Hope this work and click on start. Alright, so the estimated outbound data is 4.5 GB. Hopefully this time it works after the validation. Okay, it started, so it's in the queue. Looks like some activity is happening from the breaking point side. The attack has begun to the target IP address which we have given. Alright, so looks like the whole 10 minutes have passed and our trial is also ended, so I hope this works. The DDoS attack has happened, so I'm just waiting for Azure to let us know if it picked up any sort of attack. So hopefully we should be able to see something soon. I'm not able to see anything as of now. It's been more than 10 minutes. Let us go and do one more test. Now I'm gonna quickly refresh and we're gonna go to metrics and select under DDoS attack or not. Under DDoS attack or not. Aggression is max. Yes, it worked. Right, so you can see clearly a spike right now which mentioned that okay, we initiated a DDoS attack to this public IP address, and we can see that the DDoS attack is being happened to this particular account. So in this lab exercise, we are going to create Azure Firewall. And we are going to test this Azure Firewall by creating some rules to block certain IP addresses or certain domains completely. And we're going to test this functionality in this lab. I hope you find this useful. So let's go and start this lab. As a network engineer or a security engineer in your company, your responsibility is to protect your Azure workload using various methods. One of the methods you can use is Azure Firewall. So in this exercise, we are going to go through various steps to configure and deploy Azure Firewall. I will show you some of the ways you can use Azure Firewall to configure your default route, application rule, and network rule, and test the Azure Firewall in action. So let's go and do that. One of the first tasks we are going to perform is to create a resource group and create virtual network and subnet. So let's start with creating a resource group. Let's go and click on resource groups and click on create resource group. I'm going to name the resource group as test firewall resource group, and I'm going to keep the resource in East US and click on create. The next step after the resource group is we're going to create a virtual network and subnet. So let's go to resource group itself, and I'm going to click on create within the resource group, and I'm going to type in virtual network and click on enter and select the virtual network from Microsoft and hit create. The resource group is by default selected along with the subscription because we chose resource group and we created a resource within that. Under the instance name, I'm going to call virtual network. I'm going to type in, and for the virtual network, I'm going to call it as test firewall virtual network, and I'm going to keep it in East US itself. Next, click on IP addresses. Under address space, we have 10.0.0.0/16. If you want, you can modify that and scroll down till you find subnet. Click on add a subnet. I'm going to create a new subnet called Azure Firewall subnet, and address range, what I'm going to give is 10.0.1.0/26 and click on add. Now come back to the subnet again and click on add one more subnet. This time name the subnet as workload subnet and the IP address as 10.0.2.0/24. This is where all of our workloads like virtual machines and other workloads are going to remain, and click on add. So we have added two subnets within our virtual network, and click on review plus create. After the validation, click on create. Looks like our deployment is completed. So click on go to resource to see your test virtual network. So you can check the address spaces and you can make sure that your subnet is being created as well. So we have both and we can see the available IP address. So the next task is to create a virtual machine. So I have a template built for that. So I'm going to execute that template. So I'm going to use Cloud Shell. So let's run the command to create a virtual machine. So this would ideally take a minute or so to create the right virtual machine in the right subnet. So in the Azure portal, I'm going to quickly go back to the home page and click on virtual machine and see if we can see the newly created virtual machine. So this one is a legacy or an old virtual machine I use for a different lab. So don't worry about it. So it's in a different resource group. So the one we are looking forward to is the virtual machine going to be created under test firewall resource group. So we should be able to see a test firewall resource group here quickly. I'm going to hit refresh one more time. Oh yeah, you can see that there is a new server work is being creating right now under test firewall resource group. So I'm going to quickly hit refresh one more time to see that. Okay, so the server is created and it is running. So you can click on the server work. I'm going to close the Cloud Shell and we can see that the VM is running, and let's go to networking, and we have a private IP address configured for this server, which is 10.0.2.4. Now that we have our virtual machine created, in the next task, we are going to deploy the firewall and the firewall policy. So let's go back to the Azure portal on the home page, click on create resource. Under the search box, type in firewall and search and select the firewall one which says it's from Microsoft. Click on create. I'm going to click on create. Subscription is being selected by default. Under resource group, I'm going to select the test firewall resource group we selected before or created before. Under name, I'm going to call it as test firewall 1. I'm going to keep it as the East US region, which is where we are keeping all of our resources. Availability, I'm going to keep it none. Under firewall tier, I'm going to change it to standard instead of premium. And under firewall management, make sure you choose use a firewall policy to manage this firewall. And under firewall policy, click on add new and give a name for your firewall policy. I'm going to call it as firewall test policy. And I'm going to keep it under East US as well and click on OK. Scroll down till you find choose virtual network and click on instead of create new, use existing. Under virtual network, select the test firewall network we created and the public IP address. I'm going to click on add new, give a name. I'm going to call it as firewall public IP address and click OK. Now that we have populated all the details required for us to create the firewall, hit on review plus create. This will go through a validation process and after that we can start the deployment. So the validation is being passed. So now we can click on create. So the deployment is in progress. Alright, so looks like our deployment has been completed. You can click on go to resource to go and see the newly created Azure Firewall. So under the overview pane, you can see that the firewall IP address is 10.0.1.4. Let's check the public IP address. So if you go to under settings, on the left hand side under settings, you can check the public IP configuration. So the public IP address of this firewall is 20.25.60.196. Alright, so now we have deployed the firewall. The next what we're going to do is we're going to create a default route. To create a default route, go to your home page, click on create a resource and type in route. The route table will appear. So click on route table and click on create. Make sure you select the right subscription we've been using, which is test firewall resource group. Keep the region of choice, which is East US right now, and give a name for your route. I'm going to call it firewall route. And under propagate gateway routes, make sure you choose yes and click on review and create and click on create. After the deployment of this route table, we are going to create the actual route table inside that. So we are waiting for the deployment to finish. Alright, so the deployment of the route table is completed. So let's click on go to resource. This is the firewall route we just created. Under settings tab, click on subnets. We don't have any subnets associated. So first click on associate. Alright, select the test firewall network. Then within the subnet, select the workload subnet and click OK. Now again under settings, this time click on routes and click on add. Give a name for your route. I'm going to call it firewall-dg. Under address prefix, I'm going to select IP address and the source IP as 0.0.0/0. Next hop, I'm going to select virtual appliance and next hop address. We have to copy and put the firewall address. So let's go to the Azure portal one more time. I forgot to copy the IP address of the firewall. Let's find our firewall, which is the test firewall 01. And the IP address of the firewall is 10.0.1.4. So I'm going to go back to the route table and I'm going to put that as the next hop address and click on add. Alright, so now we have added our route. The next task we're going to perform is we're going to configure an application rule. So let's go back to the Azure portal one more time and let's find the firewall policy we created. So let's go to resource groups, test firewall resource group. I'm going to scroll down to find, I'm going to sort it by type. And this is the firewall policy we created, which is firewall test policy. So select that. So what we are going to do right now is we are going to add an application rule that allows outbound access to google.com. So under settings, click on application rules and on the top, click on add a rule collection. So click on add a rule collection, give a name. I'm going to call it app collection 01. Rule collection type as application. Priority, I'm gonna give 200. The rule collection allow. Rule collection group, I'm gonna leave the default. Under the rule section, I'm gonna give the rule as allow Google. Source as IP address. Source 10.0.2.0/24. Protocol HTTP or HTTPS. Destination type FQDN. And destination as google.com. And click on add. So this is how you can add an application rule within the firewall policy. The policy deployment is in progress, so let's wait for a couple more seconds to complete that part. Alright, so the rule has been successfully added. Now in the next task, we are going to configure a network rule. So to configure the network rule, this time we have to go to network rules under settings. So click on network rules. We don't have any rules yet. So click on add rule collection. Give a name. I'm going to call it net collection 01. Rule collection type as network. Priority, I'm going to give it again 200. Rule collection action as allow. Rule collection group, default network rule collection group. Name of the rule, I'm going to add allow DNS. Source type as IP address. Source IP address is 10.0.2.0/24. Protocol, I'm going to select UDP. Destination port 53. Destination type as IP address, and the destination is this IP address. And these are the public DNS servers operated by the CenturyLink. So what we are doing is we are adding a network rule that allows outbound access to two public IP address at port 53, which is DNS port, and click on add. Now it is adding the network rule to the firewall policy. While that is happening, we can go and create a destination NAT rule. So our next task is to configure a destination NAT rule. So while our deployment for the network rule is happening, so we can just quickly go and create the destination NAT rule. So click on DNAT rules. While that is happening, it is successfully added the rule collection. So we can come back to that later. And click on add rule collection. Give a name. I'm going to call it RDP. Rule collection type as DNAT. Priority again 200. Rule collection default, which is destination network address translation or DNAT rule collection, and rule collection group as default DNAT rule collection group. Name RDP NAT. Source IP address. Source asterisks. Protocol TCP. Destination port 3389. Destination type as IP address. And here we need to provide the destination of the firewall's public IP address. So let's go to our firewall, click on public IP configuration, and let's copy this address and go back to the Azure portal and provide the public IP address and translated port 3389. Right. Okay. So let's put the destination IP address one more time. That's our public IP address for the firewall. Translated address port is 3389, and the translated port is the server IP address. So let's go and find the server IP address. Go home, the server work, click on networking, and copy the network private IP address of the server 10.0.2.4. So translated address is 10.0.2.4 and the port is 3389, and click on add. Alright, so now that task is completed. In the next task, we're going to do changing the primary and secondary DNS address for the server network interface. So go to the home page. This time try to find the server, and we need to find the network interface of the server. Go to networking and click on server work NIC, that is the network interface. On the left hand side under settings, click on DNS servers. So here we can provide the custom DNS. So again, this is not a mandatory step. So in the general Azure firewall requirement, you don't have to do that, but I'm just showing you an option to change the primary and secondary DNS server for the server if you want to do that in any case. So click on custom and we're going to provide the public IP address and we're going to add one more and hit save. So this is updating at the moment. So we have to restart the server to take this change affected on the virtual machine. So after this is complete, I'm going to go back to the virtual machine and we're going to restart. Cool. Let's go to the server, go to overview and restart. Yes. All right. So we have reached the final stage. So in this final task, we are going to test the firewall. So what we're going to do is we're going to verify that the rules are configured correctly and working as expected. This configuration will enable you to connect a remote desktop connection to the server through the firewall via the firewall's public IP address. So let's go and test that. The virtual machine is still restarting, so we have to give a couple more minutes to do our test. All right, so our virtual machine is restarted. So let's go and test the firewall now. So I'm going to open the remote desktop connection. So go to my local machine and right click and click on run and type in mstsc. So open the remote desktop, click on show options. Here in the computer name, I'm going to type in the firewall's public IP address. So let's go back and find the firewall's public IP. So I'm going to go home, click on the firewall. On the left hand side, click on the public IP address. I'm going to copy the public IP address of the firewall. I'm going to put that as the computer name and use colon and enter port number 3389 and give a username for the computer. So that's test user and I'm going to click on connect. All right, it is asking for credentials. So provide the password for the server. Click OK. Yes. All right, so now we are using the public IP address of the firewall to connect into the server environment. Now we are in the server. Let's go and test if the firewall rules are working or not. So I'm going to launch the Internet Explorer. Let's quickly close all of this. We don't want any of that. Let's launch the Internet Explorer, accept the default settings because this is the first time we are logging into the server. I'm going to accept the default and I'm going to type in www.google.com. So we should be able to access this website. All right, so we are able to access google.com. So now let's try www.microsoft.com. We should not be able to access it. As you can see that, let me increase it. The action deny reason is no rule matched and proceeding with the default action, which is deny action. So we can access google.com, but not microsoft.com because of the rule we have set. Cool. So that's the end of the deployment and configuration of the firewall and configuring the rule. So in this lab exercise, we are going to see how to use Azure Service Endpoints for certain scenarios. We're going to use Azure Service Endpoints to block communication to the outside internet world, and we're going to only restrict access to Azure storage account using this Azure Service Endpoints. And let's go and find out how we can do that. So in this exercise, we are going to create virtual network service endpoints. That is going to enable us to limit network access to some Azure resources to a virtual network subnet. So the first task what we're going to do today is to create virtual network, and then we are going to enable service endpoint. So let's go and do these two tasks now. To create a virtual network, click on create a resource, search for virtual network and select the virtual network from Microsoft and click on create. Here select the subscription and select a resource group. Since we don't have a resource group, I'm going to create a new one. I'm going to call it my resource group and click OK. Give a name for your virtual network. I'm going to call it Core Services VNet, and I'm going to place it in East US itself. Next, click on IP address. By default, there will be an address space allocated, so I'm going to retain that for this exercise. Under subnet, we have a default subnet created, so I'm going to modify that. I'm going to change the name from default to public, and the subnet IP address range is 10.0.0.0/24, and click on save. Next, click on the security tab. We are not going to enable any of these at the moment, so click on review and create, and click on create. The deployment is in progress. It wouldn't take more than a minute or so. Alright, so our deployment is complete. Click on go to resource to verify all the changes you have made. Address spaces is fine. We have the right subnet we created as well. So click on go to home. The next task we are going to do is we are going to enable a service endpoint. To enable a service endpoint, we have to go back to our virtual network. So click on core services VNets we created. On the left hand side under settings, click on subnets. On the top of the subnet, click on create a subnet. Here I'm going to give a value called private as the name for the new subnet. Subnet range is 10.0.1.0/24. That is what I'm giving. Scroll down until you find service endpoints. So under service endpoints, you can see that this is where you can create service endpoint policies to allow traffic to specific Azure resources from your virtual network over service endpoints. Under services, make sure you select and search for Microsoft Storage and select that. We are not making any other changes to subnet delegation or service endpoint policies. Click on save. Now you should have two subnets, one a public one, another one is a private one. Now the next task is to restrict a network access for a subnet. So let's go and do that. Let me go back to the home page. So for by default, all virtual machines in a subnet can communicate with all resources. So you can limit communication to and from all resources in a subnet by creating a network security group and associating it to the subnet. So let's go and create a security group. So click on create a resource. This time search for security group and click enter and select network security group. Click on create. Select the resource group as the one which we created, my resource group, and give a name for your network security group. I'm going to call it Contoso Private Network Security Group and retain the region as East US. Click on review and create and click on create. Let's wait for the deployment to complete. After the deployment, click on go to resource. On the network security group page, go to settings and click on outbound security rules. Here, click on add. So here under source, we are going to select any source port ranges asterisk destination as service tag. Under destination service tag, select storage. So search for storage and select that. Under services, select custom, scroll down. Under destination port ranges, provide asterisks for all port ranges. Protocol is any and action is allow. Priority I'm going to retain 100 and the name of the rule I'm going to give allow storage all and click on add. So that's how you create a new rule within your network security group. Now that our rule is created, let's quickly refresh and check the rule. So this is the new rule we created. So I'm going to click on add and create one more outbound rule. This outbound rule, what we are going to create is to deny communication to the internet. So this rule should override any default rule in all network security group that allows outbound internet connection. So under source, select any source port range asterisk, destination again service tag. Under destination service tag, make sure you select internet, service is custom, and the port again we are giving asterisk. Scroll down. Under protocol, make sure you select any. Under action, make sure you select deny because we want to deny any sort of internet communication. Priority retain 110. Under name, I'm going to change it to deny internet to all so that I understand what is this rule about and click on add. So we have created another outbound rule as well. So one to allow communication to storage, another one to deny any sort of internet communication. Now let's go and do the task 5, which is to allow access for RDP connections. So what we have done just now is to create the outbound rules. Next, what we are going to do is we are going to create some inbound rules. So go back to your network security group. Under settings, this time select inbound security rules and click on add. So this inbound security rule we are going to create is to allow remote desktop protocol traffic to the subnet from anywhere, so that the rule overrides a default security rule that denies all inbound traffic from the internet. So source is any, source port range asterisk for all. Under destination, select any. Service is custom and destination port for RDP is 3389. Scroll down, there is no changes in the protocol. Under action, allow priority 120, and I'm going to change the name to allow RDP all and click on add. So when you create this rule, there will be a warning. So RDP port 3389 is exposed to internet. That's why there is a warning. So this is only recommended for testing. For production environment, Microsoft recommend that using a VPN or private connection. Alright, so now we have created all the rules required. Let's go and associate it. Now that we have created all the rules we are required, on the left hand side, click on Subnets. And we don't have any associations at the moment. So click on Associate. From the drop down, choose the virtual network. So I'm going to choose Core Services VNet. Under the VNet, we have to associate it with the private subnet we created. Once you make the necessary changes, click on OK. So this is how you create a NSG or a security group and associate that rules to a particular subnet so it sticks on the policies or the rules we created. So now that we have completed that task, so in the next task, we are going to restrict network access to a resource. So we are going to create a storage account and we are going to restrict access to that storage account. In the Azure portal, go and click on create a new resource to create a storage account. I'm going to simply click on storage accounts. We don't have one at the moment, so I can create a brand new storage account. So click on create. Make sure you select the right subscription. Change the resource group to one which we are using for this exercise, that is my resource group. Give a name for your storage account. I'm going to call it Contoso Storage and some random number because this name has to be unique. I'm going to retain it in East US. Performance is standard is fine. Under redundancy, I'm going to choose LRS, which is locally redundant storage. And we are not going to make any changes in any of the other tabs. So simply click on review and create. After validation, click on create. So our storage account is created. So click on go to resource to verify your storage account. So let's look at what is the next task. Now that we have created the storage account, the next task is to create a file share in the storage account. So let's go and do that. So within the storage account, on the left hand side, under data storage, click on file shares. And to create a new file share, click on file share. Give a name for your file share. I'm going to call it for marketing. Under tier, I'm going to keep it transaction optimized and click on create. Alright, so now we have our file share created. So if you want to verify that, so click on the file share. This is where you will be able to upload, download files and connect to a machine like Windows, Linux or Mac operating system and use it as an SMB or network drive. The next task is to restrict network access to a subnet. So let's go back to the storage account we created. So by default, storage accounts accept network connection from clients in any network, including the internet. So we need to deny network access from the internet and all other subnets in all virtual networks, except for the private subnet in the core services VNet. So that is what we are going to do right now. So under security plus networking, so just scroll down and find security plus networking. Click on networking. So please make sure that you are within your storage account itself. So within this page, instead of all network, we are going to select selected network. We don't have any virtual network association at the moment. So click on add existing virtual network. Make sure you select the right subscription. Under virtual network, select if you have multiple, please be careful. So we only have one. I'm going to select core services VNet and it will populate all the subnets available within that network. So I'm going to select private and click on add. We are not making any other changes within this page. So go on top of the window and click on save. Alright, our settings is been saved. Alright, so our next task is to create a virtual machine and test if the access is working or not. So to do that, I'm going to deploy a script which is going to deploy a virtual machine so fast so that we can continue with this exercise. So creating a virtual machine is not that important for this lab. So using the Cloud Shell, I'm going to execute a script to create a virtual machine in our subnet. So let's go back to the home page and go to virtual machines. We don't have any at the moment, but soon we will see a virtual machine created. So we are actually creating two virtual machines. One is to test the private endpoint, another one is for the public access. So let's do a quick refresh to see if anything is created yet. So nothing yet at the moment. Alright, so looks like our first VM is created. So I'm going to minimize this window and click on refresh. So one is running, that means it is created, and the second one is in the creating stage. So these are the two virtual machines I talked about. One is the private one, another one is the public one. Alright, so both virtual machines are created and in running status. Now let's go and confirm the access to the storage account. So to do that, I'm gonna go to the private one. So click on the private virtual machine, which is you can create any virtual machine. Make sure you associate it to the private subnet and click on connect. Click on RDP. I'm going to download with the public IP address and download the RDP file to connect to this virtual machine. Click on connect. Give the username for the server and the right password. Click OK. Click on connect. All right, the VM is booted for the first time. So what we are going to do right now is we are going to go to the storage account and see if we can map the drive to this particular virtual machine. So we should be ideally be able to do that because we have already provided access to the storage account privately. So to do that, first let's go and find the script which is required for us to run this command. So I'm going to minimize it. So we have to go to the storage account to find the access key first. So on the left hand side for the storage account, scroll down under security and networking, click on access keys and click on show keys. So I'm going to copy one of the keys for this exercise. I'm going to copy this. Let's go back to the newly created virtual machine. I'm going to open a notepad and I'm going to save this key. And the next step is to go and find the storage account name. And we have to run a command on the local machine to make sure that we are able to access it. So I'm going to copy the storage account name, keep it as a placeholder. So now we are going to replace these values in the script below. So I'm going to copy the access key and replace the string here with the access key. Similarly, let's go and change the value of the storage account as well. Now that we have changed all the parameters which is required for us to change the access keys and the storage account, let's copy this and go to the virtual machine and open the PowerShell. And we are going to mount this storage account to this virtual machine. So we don't have any network drive at the moment. So if I click on this PC, you can see that there is only two drives. One is the C drive and another one is the temp drive. So what we are going to do right now is try to map this newly created marketing drive onto this virtual machine. All right, so we got a confirmation that we were able to map it, so we didn't get any error. So that means we have access to the storage account from this virtual machine, which is placed in the private subnet. So I'm going to quickly do a refresh. For some reason, it's still not showing as the map drive, but the connection to this storage account is being successful. So we know that that is working. So what I'm going to do right now, I'm going to run another command to ping internet access. So ideally we should get no reply access because we have created a network security group and associated it to a private subnet which doesn't allow outbound access to the internet. Now let's log into another virtual machine. This time go to the public virtual machine. I'm going to go back to Azure homepage, go to virtual machines and click on the public one and click on connect. So I'm going to log into the public virtual machine, provide the username and password to log into the virtual machine. Ideally, in this public virtual machine, we should not be able to mount the storage account we created. So we should get a access denied error, or we don't have any access to this storage account. And we should be able to ping outbound connection to the internet. So let's go to the PowerShell again. This time I'm gonna copy the command which we wrote in the others virtual machine. So let's open side by side and let's see if we can open it. So rather than typing it one more time. So I'm gonna go to the public virtual machine and I'm gonna execute this command. Here basically we should get an access denied error because we don't have, yeah, as you can see that we don't have access to access the storage account from a public virtual machine. But now let's do internet testing. So I'm gonna ping google.com. Yes, we have access to the internet. So this was the test. So you can create service endpoint to restrict access to any sort of resources, which is Azure sort of resources, to make sure that you are allowing some sort of an access and some access is denied. So in this lab exercise, we are going to see Azure Monitor in action. So we're going to create a load balancer and we're going to create the health probes and health rules, things like that. And we're going to integrate that with the log analytics workspace. Then we are going to learn how you can use Azure Monitor and log analytics workspace to monitor the workloads you host within your Azure environment. So let's go and do that. In this exercise, we are going to create an internal load balancer. Then we are going to create a log analytics workspace and use Azure Monitor Insights to view information about your internal load balancer. So let's go and do that. So the first task we are going to perform is to create a virtual network and then we are going to create the load balancer. Let's go and click on create a resource to create a virtual network. So type in virtual network on the search box. Pick a resource group or create a new one. So we don't have any, so I'm going to create a new resource group. I'm going to call it internal load balancer resource group. Click OK and give a name for your virtual network. I'm going to call it internal load balancer VNet. So pick a region. So I'm going to pick West US and select the region. Click next for IP addresses. So let's give an address space. So I'm going to give an address space of 10.1.0.0/16 and click on add a subnet to create a new subnet. So I'm going to call this subnet my backend subnet and give an address range. I'm going to give it 10.1.0.0/24 and click on add. Then click on review. Oh, so before that we have to enable Bastion as well. So click next to security and here under Bastion host, instead of disable, click on enable. Give a name for your Bastion. So I'm going to call it my Bastion host and give an address space for your Bastion. So I'm going to give it 10.1.1.0/24 and under public IP address, create a new public IP address name. I'm going to call it my Bastion IP and hit OK. So we're not going to make any other changes. So click on review and create. Hit on create. Because we are enabling Bastion, it is going to take a little more time than usually it would take to create a virtual network. And click on go to resource to verify everything what you have given is in the right order. So we have the address space listed here and we have the subnet we created, one for the Bastion and one for the backend subnet. Now the next task is to create the load balancer. Go back to the Azure homepage, click on create a resource, search for load balancer and hit enter. So let's click on the Microsoft load balancer and click on create. So under the resource group, select the internal load balancer resource group we created. Give a name for your load balancer. I'm going to call it my internal load balancer. Region is West US itself. Under SKU, we're going to select standard. Scroll down. Under the type, select internal and click on add front-end IP configuration. So here add front-end IP configuration. Give a name. I'm going to call it as load balancer front-end. Under virtual network, make sure you select the right network and select the subnet. So I'm going to select my backend subnet. IP address assignment is dynamic. click on add and click on review and create. After validation, hit on create. So load balancer is created. So click on go to resource to go to the newly created load balancer. So the next task we are going to do is we are going to create a backend pool. So let's go and do that. So within the load balancer, under settings, click on backend pools. Click on add. Give a name for your backend pool. So I'm going to call it my backend pool. Virtual network is internal load balancer VNet. And scroll down. And we are going to add virtual machines later to this backend pool. So right now we are not making any more changes. So click on add. Alright, so our backend pool is created. The next task is to create a health probe. So the load balancer monitors the status of your app with a health probe. The health probe adds or removes virtual machines from the load balancer based on the response to the health checks. So let's go and create a health probe to monitor the health of the virtual machines. So within your load balancer, under settings, click on health probes. So we don't have one, so click on add. Give a name for your health probe. So I'm going to call it my health probe. Protocol as HTTP and port 80. Path we are going to retain / interval we are going to give it 15 minutes. Unhealthy threshold it's 2 and click on add. Alright, so our health probe is being created. The next task is to create the load balancer rule. So to create the load balancer rule, click on load balancing rules and click on add. Give a name for your load balancer rule. I'm going to call it my HTTP rule. Retain IP version 4. Select the front end IP. So I'm going to select the load balancer front end. Select the backend pool. I'm going to select my backend pool. Protocol as TCP. Port 80. Backend port is also 80. Under health probe, select the newly created health probe. Scroll down. Under session persistence none. Idle timeout I'm going to give 15. And rest everything is default. TCP reset is disabled and floating IP is disabled, and click on add. Now let's go and create backend servers. To create this virtual machine, I'm going to run a script to quickly deploy 3 virtual machines for this lab exercise. I just executed the command to deploy these 3 virtual machines. This is going to take a while, so I'm going to come back later. So we're going to go to the virtual machines tab and keep an eye on if we are able to see these 3 virtual machines, and we'll come back to this later. Let's do a quick refresh one more time to see if the virtual machines are created. Okay, so our first virtual machine is created and the status is running. So soon we will be able to see other 2 virtual machines as well. Let's see one more time if it is created. Alright, so the second virtual machine is in the creating state. Alright, so all of our backend VMs are created and all of the VMs are in the running state. In the next task, we're going to add all of the VMs we created to the backend pool. Let's go and do that. Go to the home page and select the load balancer we created. So that is my internal load balancer. On the left hand side under settings, select backend pools. And within that, select my backend pool. So we haven't added any virtual machines when we created this backend pool. So now we are going to come to this tab and click on add to add virtual machines. So select all 3 virtual machines and click on add and save. Alright, so all of our virtual machines are added to the backend pool. Now in the next task, we are going to install IIS on all of these virtual machines. So to install IIS, we have to connect to all of these virtual machines. So let's go to our virtual machine, select all of these virtual machines one by one. First, I'm going to do on my virtual machine 1, go to click on connect and connect via Bastion. Give the username and password and click on connect. So if you have any pop-up blocker, please make sure you allow pop-up blocker from this website and click on connect one more time. So while that is happening, I'm going to click on connect to other virtual machines on the same time because we can execute the same process, because that is going to enable us to install this IIS servers quickly. And now I'm connecting to server 2. Now let's go and connect to server 3 as well. So now all 3 virtual machines are at the connection state. So let's go and accept all the default values. So to install IaaS, I'm going to go to the virtual machine we just booted up, and I'm going to go to PowerShell and run install Windows feature, name web server, include management tools, and hit enter. So I'm going to execute the same command on other two virtual machines as well, and run the command on the third virtual machine. You can skip these parts if you don't want to watch this. If you want to watch the next step, you can just click on the timestamp and you can go to the next task. Alright, so the IaaS has been installed. So I'm going to run another command to remove the default web page. And I'm going to add another command to create a new IaaS site which returns the value hello world. Cool. Execute the same command on the other two VMs. Alright, so now we have installed the IaaS on all three virtual machines, and we deleted the default website and we added a hello world website. Alright, so that task is done. So the next task is to test the load balancer. So to test the load balancer, we are going to create a test virtual machine and test from there. So I'm going to quickly create a test virtual machine. Go to virtual machine and click on create Azure virtual machine. Resource group, I'm going to keep it under internal load balancer resource group. Give a name for your virtual machine. I'm going to call it my test VM. Region, I'm going to retain in West US. No availability zone required because this is a test environment. Under image, I'm going to select Windows Server 2019 and give a username and password to sign into the virtual machine. Click next for the disk. We're not making any changes. We're going to retain the default. Click on networking and make sure you choose the internal load balancer network we created. And the subnet, I'm going to assign it to my backend subnet, not the Bastion subnet. Public IP, change to none. Under network security group, select advanced and make sure you select the network security group we created, so which is my NSG, and scroll down and click on review and create. Looks like our validation is failed. Let me quickly check what's the reason. So let me go and change the virtual machine size. I didn't have enough quota to create that test virtual machine, so I just quickly changed the size of the virtual machine. So let's click on create. After the deployment, we are going to connect to this test virtual machine to test the load balancer. Looks like our deployment is completed. So click on go to resource. Yep, our server is up. Let's click connect to the virtual machine and connect using Bastion. Give the username and password for the virtual machine and click on connect. Our test virtual machine is loaded for the first time. Accept the default settings. And I'm going to launch the Internet Explorer browser and accept the default settings. And now to test the load balancer, we have to find the private IP address of our load balancer. Let's go back to our Azure portal, click on home page and go and find your load balancer. And within your load balancer page, make sure you hit on overview and click on see more. And then you will be able to see the private IP address. So I'm going to copy the private IP address, which is 10.1.0.4, and go back to your test virtual machine. And I'm going to paste the IP of the load balancer and hit enter. Let me increase the size. As you can see that this is the IaaS server we installed. So if I refresh it, because we have 3 virtual machines, sometimes we get the connection from VM1 or VM2. So I'm going to quickly enter refresh multiple times so that I can see that the load balancer is, yep. Now the VM is changed from VM3 to VM2. So if you keep on refreshing, you will see sometimes result coming from VM1 as well. So our load balancer is working. So now we have our load balancer. Let's do the main exercise. The whole purpose of this exercise is to monitor the load balancer. So we're going to create a log analytics workspace now to enable the Azure Monitor. To create the log analytics workspace, go to the Azure homepage and click on create a resource. This time search for log analytics workspace and select that and click on create. Make sure you select the subscription we created and give a name for your log analytics workspace. I'm going to call it my LA workspace. Region West US and click on review and create and click on create. Alright, so the log analytics workspace is created. You can go and check the log analytics workspace. We'll come back to this later. So now let's go and do the next task. Next task we have to complete is to use the functional dependency view in the load balancer. Let's go back to the load balancer. Go back to your Azure homepage. Click on your load balancer. On the left hand side, scroll down until you find monitoring. Under monitoring, click on insights. So by default, the metrics will be open. So click close to close the metrics. So this page view is known as the functional dependency view. And in this view, we are going to get a useful interactive diagram which illustrates the topology of the selected network resource. In this case, we are going to select the load balancer. So this is the functional dependency role. So you can click on these interactive diagrams to get more details of the functionality dependency view on your load balancer. Additionally, you can download the topology. You can refresh to see any new changes, what it is made on this load balancer, etc. Additionally, you will get this zoom in, zoom out option as well. So if you want to zoom out, you can zoom out and see additional details. To download the SVG file, you can click on download the topology and that will download the SVG file. So this is the downloaded file. Now let's click on view metrics. This metrics pane provides a quick view of some key metrics for this load balancer resource in the form of bar and line charts. To view detailed metrics, you can click on view detailed metrics over here. This opens a large full metrics page in the Azure Network Insights platform. This is the first tab you will land on the overview tab, and which shows the availability status of the load balancer and the overall data throughput and front-end and back-end availability for each of the front-end IPs attached to the load balancer. And these metrics indicate whether the front-end IP is responsive and the compute instance in your back-end pool are individually responsive to the inbound connections. So to check the availability, you can click on front-end and back-end availability. And this is where you would be able to see the health probe status charts. And if you see any value that is lower than 100 for these items, it indicates an outage of some kind on those resources. On the top, next you can check is data throughput. This is where you can check the data throughput charts for the system. This is where you can gain the data throughput information. And you can hover over some of the data points in this chart and you will see the values change to show the exact value at the point in time. Another chart is flow distribution. So click on flow distribution. This is where you will be able to see charts for VM flow creation and network traffic section. Alright, so now let's go and see the resource health. To view the resource health, go to all services and search for monitor and select the Azure Monitor. On the left hand side, click on service health. Under service health, click on resource health and select the resource type. The resource type you are looking for is the load balancer. So search for load balancer and you can click on your load balancer. So the resource health page will identify any major availability issue with your load balancer resource. So if there are any events under the health history, you can expand the health event to see more detail about the event. Alright, so now we have completed the functional dependency view, detailed metrics and the resource health. Now let's go and do the last task, which is to configure the diagnostic settings. So go back to the home page and select your load balancer. On the left hand side, under monitoring, click on diagnostic settings and add diagnostic setting. So give a name for your diagnostic settings. I'm going to call it as my load balancer diagnostics. Click on all metrics and send to log analytics. So because we have a log analytics workspace created, make sure you select your log analytics workspace. And to save the changes, all you have to do is click on save. So this will send any sort of diagnostic reports to the log analytics workspace. I hope all the information provided in this lab was helpful. I will see you on the next one. Until then, take care.